Hello, hello, my dear friends. Anyone in live? Right. Okay, fine, done. Hello, my dear friends. Anyone in live? If anyone in live, just say me hi. If anyone is in live, just say me hi. Say me the voice and the video is clear. Is the audio and the video is clear? Now, anyone? The audio and the video is clear. Is the audio and video is clear? Hi Praneeth, hi. Priyansh, hi. Fine. Now video and the audio is clear. Hi Priyansh, hi. Now Priyansh, you are from? Priyansh, you are from? Yes, clear. Priyansh, you are from, and may I know, which for which entrance you are preparing? Like JEE, NEET, Delhi. Good. May I know which entrance you are preparing for? Like JEE or NEET or any other entrance? JEE means good. Okay, fine. Now I hope the audio and the video for the 2020-26. Okay, good. Good evening, Abhinay. Good evening. Now in our last class up to we have done SN1, SN2, E1, E2, E1 CB and the elimination we have done. Clear? Namaste Rishika, namaste. Done. Now today we'll do some lectures, some questions based on the SN1, SN2, E1, E2, E1 CB, some conversion questions. Then after that we'll start the class of which one? Haloarenes. Clear? Now haloarenes will start. Then after that followed by substitution, nucleophilic, ARSN, nucleophilic aromatic substitution reaction, that we are going to see. Clear? Oh, dropper, Priyansh, okay, good. Okay, I am here to help you in the organic case. Clear? Now daily I am going to give the class. The regularly now from today onwards. Now yesterday, day before yesterday, we have started the haloalkane haloarenes. Now yesterday only the SN1, SN2, E1, E2, E1 CB has been finished. Daily regularly the organic classes will run. If you are having any backlog in the organic, already the classes already recorded and it is there in my playlist. Once you go and visit over there. Good evening. Karthia. Good evening, Karthia. Clear? Now shall we start the class? If you are having any backlog, whatever the videos you have missed, it is already in the playlist, right? You can go and see over there and you can follow the lectures. Now once the okay, done, good. Once the lecture completed. Now we are having the question section also, but yesterday we have did the very interesting and very important lecture, right? Now we'll start with the asterisk. Namaste, I was waiting for you only. Okay, done. Right. Now I'm starting the class. Now we'll go with the question. Now we'll go with the question. You know, right? If you know the question, if you know the answer for that question, try to say. If not, give me the question mark. Whatever may be. Yes, I will continue everything, not only the organic. GOC, hydrocarbons, haloalkane, haloarenes, next alcohols, phenols, ethers, carbonyl compounds, amines, and next biomolecules, next after that inorganic chemistry, coordination, D and F, then after that physical solution, electrochemistry, chemical kinetics, then after that first year atomic structure. My aim is to be by the October all the chapters to be completed. From the October onwards only revision section, only question session, only the JEE mains question session. Clear? Now should I start the, is there any concerns? Is there any concern and questions to be asked? Should I start the lecture? Should I start the lecture? Everyone? Should I start the lecture? Right. Done? Now? Right. Hi Rishika. Yes, Rishika, done. Thank you. This type of the messages make me so happy, so that I can give you more content for you and I can make you the more easy in your upcoming any entrance exam. This type of the messages make me so happy. Thank you for it. Now we'll start the class. Now the last class we have completed the clear. Now in the last class we have completed the SN1, SN2, SNI, SNNGP, E1, E2, E1CB. Based on that concept only, with the application of the hydrocarbons, I was giving the one question. Try to predict the answer. Clear? Here it is not that much hard. He is saying that question 2-bromo-butane. He has given the 2-bromo-butane. This 2-bromo-butane, when it has heated with the alcoholic KOH. Okay. I was not studied in any international school, or I was not studied in any the CBSE school. I was from the SSC background, and that too the remaining everything my education was happen in the government school. So whatever my English it is there, please try to adjust, because that much I was not fluency. Okay, no problem. Okay, no problem. Right. Now the 2-bromo-butane upon alcoholic KOH, it gives isomeric butene. One is A, one is B, and C. Clear? Here 2-bromo-butane, when you are treated with the alkalic KOH and the heating, that it will give the isomeric butenes A and B and C. Clear? Then A is the minor product. A is the minor product that we got, minor product. Clear? This A upon ozonolysis, A upon ozonolysis, A upon ozonolysis gives, after completion of entire organic chapters, I will start the surface chemistry. A upon ozonolysis gives formaldehyde, A upon ozonolysis give formaldehyde, and another aldehyde, another A upon formaldehyde, it will give another aldehyde. Now, clear? In a equimolar amount, equimolar amount. Now, what are the products? What are the products? A, B, and C. What are the A products? A, B, C. Can you say me the IUPAC? This is somewhat like, instead of giving the structures, I was written it in the what? IUPAC form. One statement based question type. Sir, A is but 1 in. Okay, good. A is but 1 in. Then what are the B and C? A is but 1 in means what are the B and C? Rest any other? Try to give me the answer, Anna. B and C, I think, B and C, you think? Trans and cis butane. Good. Clear? Now, here 2-bromobutane. This is a 2-bromobutane. Now, 2-bromobutane upon alcoholic KOH. Alcoholic KOH. Here we are having the two possibility. Two possibility we are having. Now, the hydrogen, it can be hydrogens, it can be eliminated from the terminal end, and the hydrogens, it can be eliminated from the internal end. If it is eliminated from the yes asterisk, you can ask if it is eliminated from the internal end, what it will give? One, it can give you the transalkene. One, it can give the transalkene, and one, it can give you the cisalkene. One, it can give you the cisalkene. Vipul, you can also become the topper. Next, if the OH, if it is abstracted from the internal or terminal end, now here the what? Another type of the alkene will get, that is but 1 in. Now what is saying? The but 1 in is a minor product. This one we call it as a Hofmann product. This we call it as a Hofmann product. Now this one we call it as a cis and trans. Now these are the sets of product. Nothing. This is E2 reaction. This is E2 reaction. Alkali halide upon any strong base, upon heating, what it will give? It will give you the one alkene, one the set of alkene. That set of alkene, one it is a trans, one it is a cis. Clear? Another type of is also possible, that is a but 1 in. But 1 in. This but 1 in only upon, if you do the hydrolysis, one you will get the which one? 1, 2, 3. One you will get the propanol, one you will get the formaldehyde. This is only the one question. Clear? Is it clear? Is this question is clear for everyone? Is this question is clear for everyone? Now we'll move to the another question. Now here he has given the what? C2H5Cl upon KCN gives A upon hydrolysis gives B. What is the B? Thank you. Now Now what is the IUPAC name of the B? What is the IUPAC name of the B? C2H5Cl upon KCN gives A upon hydrolysis gives B. What is the IUPAC name of the B? What is the IUPAC name of the B? What is the IUPAC name of the B? Ethanol. Ethanola. Ethanol. No, not ethanol. Once you cross check once again. But it is not the ethanol. Ethanol is not the answer. Ethanol is not the answer. Propanol. No. Alcohol functional group you will not get. There is no any chance to get the alcohol functional group. There is no any chance of getting the alcohol functional group. Should I explain or rest any other they will try? Any other they will try? Try to give the answers whether it is a correct or wrong. I will explain. If you try something, you will get. Now, ethyl chloride upon KCN gives A upon hydrolysis gives B. What is the B? Should I explain? Or will you try? Should I explain or will you try? Propane. No, not propane. No, there is no any alcohol functional group in the question. I was saying whatever the product you are getting, there is no any alcohol functional group. Alcohol functional group undadu. Right, done. Clear? Now here, yes, this is a Cn minus, right? Now this is a CH3, CH2, Cl. Now we know this cyanide Cn minus is a strong nucleophile. Now very fastly it will be attacked and the Cl will be eliminated. Then we will get the what? Here this is a nitrile group will be added. Done. Clear? When this nitrile group it is added, this nitrile upon hydrolysis, it will give you the carboxylic acid. It will give you the carboxylic acid. Already I explained very clearly. This is the cyanide. Now the cyanide, nitrogen being the more electronegative. Now carbon will get the positive charge and the nitrogen will get the negative charge. Now this is oxonium ion, sorry. This is a hydronium ion. This hydronium ion we are having the plenty of H plus. Then in the plenty of H plus, now the H plus and the OH minus. Now the less one will be attacked to the less electronegative will be attacked to the more electronegative. Now the more electronegative will be attacked to the less electronegative. Due to that what it will happen? Now the 3 hydroxy groups, because here the nitrogen it will take all the H's from the H3O plus and the ammonia it will be eliminated. Now what will get? 3 hydroxy groups will be added in this manner. We know, right? Carbon bearing the, which one? Carbon bearing the 3 hydroxy groups are unstable. Then the elimination of the H2O will take place and it leads to give the carboxylic acid. It leads to give the carboxylic acid. Clear? Is it clear? Is it clear? Yes sir, done. Right. Next question. Next question we are having. Now dehydrohalogenation of ethyl chloride. Dehydrohalogenation of ethyl chloride. Now, ethyl chloride, what are the following changes occur? Following changes occur. What are the following changes occur? What are the following changes occur? What are the following changes occur when the ethyl chloride is it? First one, A, sp2 carbon converts into sp3 carbon. B, sp2 carbon converts into sp carbon. C, sp3 carbon converts into sp carbon. D, sp3 carbon converts into sp2 carbon. Now what is the answer? Answer is D. Good. Answer is D. How? This is the ethyl chloride, right? Ethyl chloride. Ethyl chloride upon dehydrohalogenation. Dehydrohalogenation, either it is alcoholic KOH upon heating. Elimination. Now this hydrogen it will be eliminated and this chlorine will be eliminated. Now whatever the sp3 carbons are there, that has been converted into sp2. That has been converted into sp2. Clear? Done. Right. Next one question. Now 1-phenyl 2-bromo butane with NaOMe. Major product IUPAC name. Major product IUPAC name. 1-phenyl 2-bromo butane with NaOMe. Now major product IUPAC name. Major product IUPAC name. Major product IUPAC name. Major product IUPAC name. Sodium methoxide 1-phenyl 2-bromo butane when it has reacted. What is the major product IUPAC name? What is the major product IUPAC name? What is the major product IUPAC name? SN2 kada. Elimination. That is a strong base. Sodium methoxide. It is a strong base. Elimination reaction will be happen, not SN2. Sodium methoxide is a strong base. Elimination. Elimination reaction will take place. One-phenyl 2-bromo butane with NaOMe, major product of the IUPAC. One-phenyl butadiene. One-phenyl butadiene. One-phenyl butadiene. Is it correct? Is it correct? One-phenyl butadiene. Now let's see. Now what he has given? 1 phenyl 2 bromo butane. This is a butane. Now this is a 1 phenyl. Now this is a bromine. This is a bromine. Clear? Now here then the NaOMe. NaOMe. Once you cross check, is there any other chance? NaOMe. This is 1 phenyl. Butanene. That is butanene. 1 phenyl butanene. Here this OMe, this hydrogen, here it is a stable hydrogen, right? Now when it has taken this one, now as the Br it will be eliminated. This type of the simple mistakes only you are going to do. Now this is a alkene carbon should get the least, right? Alkene carbon should get the least. But here the hydrogen is more stable, right? Here the benzyl alpha hydrogen is more stable, right? This is 1 phenyl butanene. 1 phenyl butanene is the answer, not butadiene. Done? Right. Now next we'll go to the another question. Now CH3Cl upon KCN gives A. Okay. Now this A upon hydrolysis gives B. This B upon C2H5OH plus H plus upon heating gives C. What is the IUPAC name of the C? 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 Now try to give the answer. If you know, say me. If not, I will say. What is the answer? If you know, try to say. If not, I will explain. Sir, 1 degree elimination, will it happen? 1 degree. 1 degree alkali halide upon strong nucleophile SN2 will happen, right? Why the elimination will be happen? This is SN2 reaction. Why you are thinking about the elimination? This is 1 degree. Yesterday I explained you, right? 1 degree alkali halide. Where? Now you can see here. Yesterday SN2 1 degree alkali halide 2 degree, 3 degree, and the rest other 3 degree, 2 degree, 1 degree. Now 1 degree alkali halide upon the strong base, what it will readily undergo? It will readily undergo SN2 reaction, right? Last step also I explained. Last step. What is a B? You say me the B. What is a B here? What is a B here? What is a B here? Ethanoic acid. Ethanoic acid upon the alcohol. See, first one A, this one will readily attack to this substrate and the Cl will be eliminated. Then what it will get? Now CH3, Cn. Ethane nitrile you will get. Ethane nitrile upon hydrolysis you will get the ethanoic acid. You know, right? Ethanoic acid. Now this ethanoic acid, when it is reacted with the alcohol, what it will happen? Now this is a esterification reaction. Now you will get the ester. Clear? Now what you will get? You will get the ester in this manner. Ester you will get. Is it clear? Ester you will get. Methyl, ethyl, ester. No, this one ethyl. Oxygen. See, this oxygen attached, this single bonded oxygen attached alkali should be given the first priority. This is ethyl 108. This is the ethyl should be given the high priority. Ethyl ethanoate. IUPAC name is ethyl ethanoate. This oxygen attached alkali should be given the high priority. Ethyl ethanoate is the IUPAC name, not methyl ethyl ester. What I am saying, this oxygen attached alkali should be given the high priority. Then only you have to go with the parent carbon chain followed by what? Root word and the 1 degree suffix and the 2 degree suffix. Okay, right. Next one, another type of the conversion question from the SN1 and the SN2. Br plus Mg dry ether. This is dry ether. Gives A. This A upon H2O gives B. Now say me the answer. What is the B? What is the B? What is the B over there? What is the B over there? And the next conversion also I will give you. Next conversion is a CH3 CHBr CH3 upon alcoholic KOH gives A. Now this A upon HBr peroxide gives B. Clear? This B upon NaI acetone gives C. What is the C? What is the C? What is the answer? First one and the second one. For the first one and the second one, what is the answer? The one who are in the online, once try to give the answer. If you know, well and good. If you don't know, give me the what question mark, so that I can have some idea that you are listening, or I can give you more content. More I can give you. Cyclohexane 1-ol. How come cyclohexane 1-ol? How come it is cyclohexane 1-ol? Now listen. Here this is 1-bromo cyclohexane. 1-bromo cyclohexane. Cyclohexane. Then how come it will be the cyclohexane 1-ol? This is dry ether. What it will give? First it will be converted into the Grignard reagent. It will be converted into the Grignard reagent. Grignard reagent upon H2O, H plus and OH minus, right? Now the Grignard reagent is which one? Is it will take this bond pair of electron, because metal always will be exist in the which nature? Electropositive nature, right? So very fastly it will abstract this proton and it will be converted into the cyclohexane, and it will be converted into the magnesium hydroxybromide. Clear? In this manner it will be good. Now try to say me the answer for the second one. Try to say me the answer for the second one. Try to say me the answer for second one. Try to say me the answer for second one. One iodopropane. May I know what is the reaction name of this one? What is the reaction name of this one? May I know what is the reaction name of this one? Sir, Ni-acetone. Ni-acetone only. That one only I am asking. Ni-acetone. Frinkelston. Good. Frinkelston reaction only. Now you see, this is the alcoholic KOH. First one, alcoholic KOH. Then the elimination reaction will take place. In the alcoholic KOH, elimination reaction will be takes place. This is the alcoholic KOH. Now we readily abstract the base. Now the Br will be eliminated. Now what will get? Right. First we'll get the prop-1-ene. Prop-1-ene upon HBr organic peroxide. What you will get? We'll get the anti-Markovnikov addition product. That is a 1-bromo propane. 1-bromo propane upon sodium. What they have given? Sodium iodide acetone if they have given. Sodium iodide if they have given, that is a Frinkelston reaction. Now the bromine will be eliminated and the iodine will be added. So 1-bromo propane. Done. Right. Clear? Right. Next question. CH4 in the presence of Br2 HNu. Br2 HNu gives A. This A upon sodium dry ether. Sodium dry ether gives B. Again this B upon Br2 HNu gives C. This is C upon again sodium dry ether. What is the D? What is the D here? What is the D here? What is the D here? Butane, sir. Good, good, good. Clear? Now the first here it will from the halogen and the Woods reaction. Good, good, good. Halogen and the Woods reaction. First is the halogenation. Then after, sir, free radical substitution reaction. Then after that, photohalogenation, halogenation and the Woods reaction. Then after that, it will become the what? Sorry, not this one. First one. First one will be the CH3Br. After that CH3Br, it will become the ethane. Then after became the ethane upon the, again if you do, you will get the C is ethyl bromide. Then again ethyl bromide upon dry ether Woods reaction, you will get the butane. Good, good. You will get the butane. Clear? Done? Now, next. Next question. Now, one question I will write. Now, alkali halide on reaction with sodium in presence of ether gives 2, 2, 5, 5, tetramethyl hexane. The alkali halide is. Now try to say me the answer. The alkali halide is. Now what is the alkali halide here? What is the alkali halide over there? What Getterman coach? Space. What is the what Getterman coach? Prince, I did not get you. Hoffman bromide degradation. What Hoffman bromide degradation? I did not get you. No. Hoffman bromide degradation. There should be the acid amide. No. See, for the Hoffman bromide degradation, there should be the acid amide. Acid amide, it should be there. To show the Hoffman bromide degradation, acid amide, it should be there. So to show the Williamson ether synthesis, it should be there the what? Epoxide upon alkali halide it will give. Then what he is saying? Alkali halide on reaction with sodium and the dry ether. Sodium and the dry ether gives 2, 2, 5, 5 tetra methyl hexane is saying. The what is the alkali halide? Now what is the answer? Okay, fine. Prince, now you are the dropper for NEET or dropper for JEE? One halo 2, 2 dimethyl propane. Good, 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 good. 1 halo, 2 comma 2 dimethyl propane. Good, Nana. Good, good, good. If it is a chloro, any halo means okay. Good, good. 1 chloro, 2 comma 2 dimethyl propane. Clear? 1 chloro, 2 comma 2 dimethyl propane. It will give you the 2 comma 2, 5 comma 5 tetramethyl hexane. Tetramethyl hexane. How? Here the Woods reaction it will go. Sodium in the presence of dry ether. Sodium in the presence of dry ether, it will be eliminated. Now here you will get the radical. Now this radical and this radical will form the bond and you will get in this manner. Okay, now you can see 2 comma 2 and 5 comma 5 tetramethyl hexane. So the alkali halide is 1 halo 2 comma 2 dimethyl propane. 2 comma 2 dimethyl propane. Is it clear? Okay, okay. JEE, good, good, good. JEE dropper or you are going to appear for 2020-26? JEE dropper or you are going to appear for 2026? Now next one. Next question. Next question we are going to see. Now next question, it is somewhat tricky and somewhat very important. Here Me2 double bond CHCl upon sodium amide. Okay, upon sodium amide. Here what is the product name? 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 Ah, good, good. Because this is a which one? This is vinyl halide. This is vinyl halide. Vinyl halide, even though NH2 minus is a strong base, even though it is a strong nucleophile and even though it will act as a strong base, here it is not having the to eliminate. It cannot remove this vinyl chloride. It cannot remove this vinyl chloride. There is no any product in this one. Clear? There is no any product in this one. You have to be very careful. Clear? Next. Next. Now, right. Here, next one. This is a one substrate they have given. This is a one substrate they have given. Upon H plus heating. Upon H plus heating. Now what is the IUPAC name of this major product? What is the IUPAC name of major product? Major product IUPAC name. Major product IUPAC name. Major product IUPAC name. Try to give the answers. The one who are in the live, try to give the answers. Okay, so that I get to know that you are listening. Even though if it is correct or wrong, try to give. Trying is very, very important. One comma two dimethyl cyclohexavanine. Good, good, good. Good, Nana, good. Here this oxygen, this OH, it will take its bond pair of electron. When it has taken its bond pair of electron, now here this carbon will, oxonium ion, it will be taken, because after it will get the OH plus oxonium ion it will form. Now it will take this bond pair of electron and it will be eliminated, and here will get the positive charge. And here we are having the methyl. Yes. Now here what we are having, here the 1 comma 2 hydrate transfer will be happened. Here hydrate will be there, 1 comma 2 hydrate transfer will be happened. Then after that we will get the 3-degree carbocation. Then here we will get the 3-degree carbocation. Then elimination, we are having the chance to get the carbocation from here 1 number carbon and the 2 number carbon. He is asking the major product, right? So the major product, hydrogen will be eliminated from here. Then you will get the major product here. So 1 comma 2 dimethyl cyclohexavanine. That is good, good. Now here next if suppose if they have given in this manner, then H plus upon heating, then now what is the product name? What is the product name? What is the product name we will get? One comma 4 dimethyl cyclohexavanine. Good, good. 1 comma 4 dimethyl cyclohexavanine. Good, good. Right. Now next we are having one question I will search. Now I will write the product. Now I will write the some substrates. You have to say me which of the following, the given major product of the following elimination reactions. Okay, which reactions it will undergo, which one will be the major product, you have to say me. Okay. Now major product formed by which elimination? Okay, major product, I will write the substrate, you have to say me the major product will be formed by the which elimination, you have to say me whether it is a SN1, whether it is a E1, E2 or E1 CB. Okay. Now the first substrate will be in this manner. OH minus. Now the major product will be formed by which mechanism? Major product will be formed by which mechanism? E1, E2, E1 CB. E1, E2, E1 CB. Now second one, B. This B will be formed by the which mechanism? B is E1 CB. Good, good, good. B is E1 CB. Okay. Fluorine, by you are seeing the fluorine, you have said that it is a E1CB. Okay. Then A, what is about the A? What 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 happened, Anna? What you are thinking? What about the A? E2, that's it, right? Very fastly it will abstract the proton. Very fastly it will abstract the proton and it will be eliminated. Now what it will get? Here it will get the alkene, right? You will get the alkene in this manner. That's it. This is E2 mechanism. This is E2 mechanism. Why to think about that in that? Next one, if they have given. No. Now you have to say me. No. Here this is a strong base. Here the alkali chloride, if it is want to become the chlorine, here any heavy highly reacted metal it should be there. If it is want to become the E1, this OH, it is not having abstract to make it proton. This OH minus, it is not having that much strength to make it as a, to leave from this substrate to make the carbocation. This OH minus is not having that much chance. If it is want to make the carbocation here, it should be the heavy metal. Clear? There should be the high reactive metal. Only the high reactive metal only can be eliminate this Cl and make the carbocation. Clear? Done. That's the reason only the E2 is possible, not the E1. Is it clear? Is it clear, Pranit? Right. Next one. Now next one. Now this one. Alright, okay, fine. Now this one, which mechanism it will follow? E1, E2, E1CB. 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 Which mechanism it will follow? E1, E2, E1CB. Which mechanism it will follow? E2. How come E2? How come, Pranit? How you are saying this is a E2? How come it is E2? Minor product. Here this is having the chance to, here the E1 reaction involves the formation of carbanion intermediate. If you take, listen, if you think it is a E2, hydrogen should be eliminated from the trans, right? Hydrogen should be eliminated from the trans. Then here this will take the hydrogen, and here it is a hydrogen, and here it is a hydrogen. If this base, if it is acting as a base, this OH minus, if it is taken this one, now here this bond will form and here the Cl will be eliminated. Due to that we are getting the less half-mind product, right? We are getting the half-mind product. If you think this as a E2 elimination, if it is undergo it as a E2 elimination, then you are getting the less substituted alkene. Then that's the reason still we can make the more stable carbocation for this one. Now, how to make the more stable carbocation for this methoxy in this condition, for this in this substrate, what it will happen? First it will be eliminated by the HCl. Clear? Now when it is eliminated, in this case you may get a doubt, sir, here why it is not happening? Here the elimination it can happen very fastly, E2, because it is giving the stable alkene. But here also if it is undergoing the E2, but it is giving the less product, less substituted alkene. But here in this substrate itself it can rearrange to give the more stable alkene. That's the reason the first here the carbocation will be formed, then after that the rearrange will be happen, then it will be rearranged. Then when it has rearranged, then we will get the more substituted alkene in this manner, right? More substituted alkene in this manner. So that's the reason this reaction will undergo E1, not E2. This reaction will undergo E1, not E2. Is it clear? Is it clear? Rest any other? Any other are there? Clear? Rest any other are there? Now with the epoxides we'll see. With the epoxides now we'll see the reaction. Now how the reaction it will give with the epoxides. Okay, fine. Am I anyone are in the live? Once you say me hi. Other than Pranit, if anyone are in the live, once you say me hi, so that I can interact with you also. The only one is interacting with me. The one who are in the live, once you say me hi, so that I was only interacting with you, only one. I was only interacting with one. Rest any other? Rest any other are there? Okay, E is B. Okay, here it is a A and here it is a B. Now which mechanism it will follow? Which mechanism it will follow? Which mechanism it will follow? Which mechanism it will follow and where it will be attacked? For this one, which mechanism it will follow and where it is attacked? Which mechanism it will follow and where it will attack? Which mechanism it will follow and where it will attack? What is the B and what is the A? A will follow which mechanism, B will follow which mechanism, you have to say me. A will follow which mechanism and B will follow which mechanism? A will follow which mechanism and B will follow which mechanism? A will follow which mechanism and the B will follow which mechanism, you have to say me. A will follow which mechanism and the B will follow which mechanism? If you know the answer, try to say. If not, rest any other? Rest any other who are in the live? The rest any other, will you try? Should I explain? Should I explain? Okay, fine. Right. Here this one will follow the SN1 reaction, SN1 mechanism, and this one will follow the SN2 mechanism. Now you see this one which is a methyl alcohol, and he has given there is no any solvent they have given. Here there is no any solvent they have given. This MEOH will be act as a nucleophile, but here they have given the solvent, you see H plus. H plus is a polar protic solvent. This is a polar protic solvent, we know. Clear? Now here they have not given any solvent, they have not mentioned any solvent. Then MEOH will be act as a nucleophile. Then it will very fastly it will go and attack here, and this bond pair of electron will be shifted here. Clear? Now this bond pair of electron, it will be attacked to the less substituted. then the product for the B will be in this manner. OME. This is a B. Now here the polar protic solvent if they have given, then due to that polar protic solvent, now this lone pair of electrons of this epoxide lone pair of electrons, this epoxide's lone pair of electrons will be abstract. Then when this lone pair of electrons abstract, now oxygen will get the positive charge. Then after that, if this bond pair of electron was given, you will get the more stable carbocation. There you will get the more stable carbocation, right? After getting the more stable carbocation, now here we are having the which one? Nucleophile OCH3. This it will go and attack, and here it will get the H plus. That's it. Simple. Okay, you have to be very careful with this type of the reagents they have given. With this type of questions also they will make you confuse. This only this one H plus it will give the SN1. Now without any H plus it will give the SN2. Is it clear? Okay, fine. Clear? Done. Next type of the one type of the question I will give you. Predict the alkane that would form the fine. Next one the question. Next. Wait. Next question. Right. With the epoxide, so that it will be all type of the questions, it will be clear for you. Then here the Me, then here it is a CH3 Mg iodide in the presence of H2O. Can you say me the product name? And this is a one, and the second one will be the here this is a Me. Now here it is a epoxide. Now here it will be the CH3 CH2 CH methyl iodide in the presence of OHH. Clear? Now what are the product in A, and sir what are the product in 1 and what are the product in 2? Which mechanism A is following, which mechanism B is following, sorry, which mechanism 1 is following, which mechanism 2 is following, which mechanism 1 is following, which mechanism 2 is following. Which mechanism it is following? It is very nice question. This is one of the good nice question. This is one nice question. This is one nice question. Which type of the mechanism it will follow? If you know, you try to say. If not, I will explain. First one is SN1. What benzaldehyde? Where the benzaldehyde has came? Prince, from where this benzaldehyde has came? SN1, Pranit, SN1 is of which one? SN1 is of which one? Tertiary butoxide. No, this is a Grignard reagent. This is Grignard reagent. First, sir, benzene. No, first one, okay. First one I will explain. Listen for the first one. First one, it is somewhat the tricky type. Here you are thinking that it is a SN1, but actually it is not the SN1. Now listen, why it is not the SN1, I will explain. You are thinking it as a SN1 only, but for the SN1, here the Grignard reagent CH3 minus, this is CH3 minus and MgI, this is will be act as a nucleophile. Here it will be act as a nucleophile. Then this nucleophile to be attacked, there should be the carbocation, it should be generated. If suppose if the carbocation is generated here, if this bond pair of electron has been shifted here, then here the carbocation will be generated in this manner. How? Now this is a 1 degree carbocation. Here the 1 degree carbocation is, this is less stable, because to undergo the SN1 reaction, I was explaining on the basis of your understanding. If it is undergo SN1 reaction, it should generate the carbocation. But here this is a 1 degree carbocation, it is not having any chance to break the bond from here. Then if we are having a chance to break the bond from here, then here this will get the carbocation. Here it will get the alcohol and here it will get the carbocation. Okay, after getting the carbocation, clear? Now what we are having? CH3 we are having. CH3 as a nucleophile, it will go and attack. Then what is the product we'll get? Now this is a product we'll get. This is a product we will give. But this product is not absorbed. It will not be absorbed. Why it will not absorb? Because this is an SN2. If you think it as a SN1 reaction, the less substituted carbon, what it is holding, the nucleophile would be have been attached to the more substituted carbon. This nucleophile should be attached to the more substituted alkene due to the formation of the less stable carbocation, now giving the B isomer which is not absorbed. Clear? That's the reason we may think that this is a SN1 reaction, but here the SN1 reaction is not possible for this one. It will readily undergo the SN2 reaction. Is it clear? Why? Here the SN1 reaction, the nucleophile would have been attached to the more substituted carbon. Hi Ishan. Hi. Yes. Nucleophile should be attached to the more substituted. It should be attached to the more substituted. Nucleophile would be have been attached to the more substituted carbon due to the formation of the stable carbocation. Here this is not absorbed. It will be not absorbed. Even though due to the formation of the stable carbocation, here you may think that this is a 2 degree carbocation, but giving the B isomer is which is not at all absorbed. Nucleophile itself, it should be attacked. So the first, the reaction will be, now the reaction will be happened in this manner. This nucleophile which it is there, MgI, it will go and attack here. Then this bond pair of electron will be shifted. Then what it will get? Here we will get the OMgBr. In this manner the Grignard reagent will be formed. The Grignard reagent upon hydrolysis, again it will give the hydrolysis. Now this type of the alkene it will form. This type of the alcohol it will form. There you can see, here it is nucleophile is attached to the lesser substituted carbon. This is 1 degree carbon it has attached, but here it has attached to the 2 degree carbon. Is it clear? That's the reason here the SN2 reaction will be happen. SN2 reaction will be absorbed in this case. Okay, done. Now in this case, in this one, second one, which mechanism it will follow? For in this case, which mechanism it will follow? The one who are in the live, try to give me answer. The only one is interacting with me. Rest all other just they are watching and they are going, but the some other are watching but they are not at all responding. Actually, if you interact with me, the more I can get to know the more what are the problem you are facing, where you are facing the problem, so that I can clarify you, or else I can give you any suggestions. Clear? Now this will readily undergo the SN2 mechanism. That's it. Simple. Very fastly it will readily undergo the SN2 mechanism. Okay. Now I hope all the types of the questions I was explained. Almost all the types of the questions from the basics to the advanced I explained very clearly. Sir, the product I got. Good. Okay, fine. Okay, Nana, fine. Right. Now I was moving to the which one? Now I was moving to the concept now. Clear? Right? The anyone is in the live? Once you text me hi. If anyone is in the live, you just text me hi. So now I am going to start the concept. That is the next very most important concept that we are going to see from the which one? Haloalkane and the haloarenes. That is reaction with ambident nucleophiles. Reaction with the ambident nucleophile. This is a very important. Now in the last year mains they have stressed the one question from here. Sir, second reaction undergo SN2 ring opening of epoxide by Grignard reagent. Yes, good Nana Ishad. Yes, good. The next one we are going to see the reaction with the ambident nucleophile. Now in the reaction with the ambident nucleophile you have to be very careful whenever they have given the NaCN and AgCN. NaCN and the AgCN if they have given. NaCN if they have given, this is the ionic end, Na plus and Cn minus. Clear? If suppose the AgCN if they have given, Ag and the Cn, this is having the covalent character. This is forming the covalent bond. Due to this covalent bond, here the Ag plus and here the which one? Nucleophilic side will be the from the nitrogen end, not from the carbon end. Here the nucleophilic side will be from the nitrogen end in the AgCN, and here the nucleophilic side will be from the carbon end in the NaCN. This is very important, and they will stress with the names. Cyanide and the isocyanide. First, and with this type of the nucleophiles if they have given also, they will ask you which reaction it will undergo. If suppose the first 1 degree alkali halide if they have given, 1 degree alkali halide upon NaCN and KCN. NaCN and the KCN. Now what is the products you will get, and which product is major and which reaction it has followed. Now you see me, for the this is A and this is B. A and B has followed which mechanism, and what is the major product in the A and what is the major product in the B. What is the A and B? What is the major product in the A and what is the major product in the B? Sir, does AgCN attacking using nitrogen lone pair because there is a covalent bond and any other reason? What? Due to that covalent character, between the which one? Between the Ag and the Cn, it may not give directly. A is CH3 CH2 Cn and B is CH3 CH2 NC isocyanide. One you are saying that one is a cyanide is major, and which mechanism it has followed? Ishan, which mechanism it has followed? Okay, you are saying that ethyl, this is a CH3 CH2 cyanide. Propane nitrile is a major product you are saying. Okay, good. Then here it is a isocyanide. Now isocyanide is a major product you are saying. But my question is, which mechanism it has followed? 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 SN2, good. SN2 mechanism, because 1 degree alkali halide will readily undergo the SN2 mechanism. Clear? 1 degree alkali halide, it will readily undergo SN2 mechanism. Done. Next one. Next one. If suppose 2 degree alkali halides, if they are given 2 degree alkali halides, polar protic solvent often used favors SN, polar aprotic solvent offers SN2. Yes, good. Then next. Now this is a H. Now this is a Cl. Now here NaCN and AgCN. Clear? Now what are the product major here and which mechanism it has followed? Sir, primary halide, no carbocation stability, SN1 is ruled out. Okay, good Ishan. Now here 2 degree alkali halide they have given. Then 2 degree alkali halide upon 2 degree alkali halide. Now what it will give? Which mechanism it will follow and what are the major products it will give? Which mechanism it will follow and what are the products it will give? Now for the 1 degree you can rule out the SN1. Then for the 2 degree you cannot rule out the SN1, right? Then which mechanism it has followed? I was asking the mechanism. Which one I was asking? I was asking the mechanism. Which mechanism it has followed? For the 1 degree you can rule out. That is okay. For the 1 degree case you can rule out. With NaCN it will be it will follow the SN2. Good Ishan, good. Because the Cn minus is a strong nucleophile. Cn minus is a strong nucleophile. Now with the strong nucleophile SN2 reaction is favorable. SN2 reaction is favorable. Good Nana, good. SN2 reaction is favorable. Right. First one is SN2, second one is SN. No, both are SN2 only. SN2 mechanism only, because this is a Cn minus, right? Cn minus being the strong nucleophile, it will readily undergo the SN2 reaction only. But the product here is one is a cyanide, one is a isocyanide. The product here, one is a cyanide and one is a isocyanide. But the mechanism is a SN2 only. Clear? Next one. The next one we are going to see CH3, CCH3 and the CCH3, and the next one we are having the halogen, or we'll take the Cl. Now upon next one, upon we are having NaCN and AgCN. NaCN and the AgCN. Now which reaction it will follow and what is the mechanism it is involved in? Now 3 degree alkali halide upon NaCN and the AgCN. Sir, no. Sir, here AgCN we are having the Cn minus. not free, so it must be bound with Ag plus na. So being the weak nucleophile, it cannot do SN2 easily. What it cannot do the easily? Nitrogen. So no sir, here the AgCN where NaCN not be so free. It must be bound with Ag plus na. So weak nucleophile, it cannot do the SN2. But cyanide and the isocyanates are the strong nucleophiles only. I thought so. No. Cyanide and the isocyanates are the strong nucleophiles only. That's the reason it will readily undergo the which one? SN2 reaction only, not SN1. There is no any chance of forming the stable carbocation only. To show the SN1 reaction, there should be the carbocation. Now you say me in the NaCN and the AgCN, which reaction it will follow and what are the products you will get? Which reaction it will follow and what are the products you will get? Which reactions it will follow and what are the products you will get? Both will be SN1. Both will be SN1. Both are wrong. Here the reaction will not follow the SN1. Here the reaction it will follow SN2. 3 degree alkali halide upon the strong. Here for the 3 degree alkali halide, NaCN and the AgCN will be act as the NaCN and the AgCl will be act as the alkene. Here NaCN and the AgCN for the 3 degree alkali halide, it will be act as the alkene, and here the elimination reaction is favorable. Both the cases elimination reaction is favorable. Both the cases elimination reaction is favorable. Here the E2, not SN1. I know you will say it as a SN1. So this type of the question they will stress. There is no hydrogens. Sir, SN2 is impossible. That's the reason only. Here it is there, right? This is not the polar protic. Here there is Nana. What is the first thing to show the SN1? To show the SN1, there should be the polar protic solvent, right? There should be the to show the SN1, there should be the polar protic solvent. But this is the NaCN and the AgCN are not the polar protic solvents, right? These are the just nucleophile. But when it comes to the 1 degree alkali halide and the 2 degree, but when it comes to the 3 degree alkali halide, there is no any solvent only. When there is no any solvent only, how come the SN1 will give you? SN1 it is no chance only. There is no any solvent it is involved here. And Cn minus being the strong nucleophile and the strong base, it will readily abstract the proton from this adjacent carbon. From this carbon it will readily abstract. Now when the proton, when it has abstracted, now this bond pair of electron will be shifted here and the Cl minus will be eliminated and will give the elimination product. And will give you the elimination product in this manner. Is it clear? Is it clear? Is it clear? E2. Sir, how can be E2? Here only it is there, right? Trans to it. All are symmetry only. Why you are getting confusion? Pranit, why you are getting confusion here? All are symmetry only. In this, for this chlorine, all are symmetry only. You can write in this manner. From here it is eliminated and the Cl it is given. Now only the E2 is chance. OT, only the E2 is chance. There is no any other chance. There is no any other chance for here. When the 3 degree alkali halide they have given, only E2 is possible, not the SN1. Try to remember, this is very, very important. Very, very important. Here only the SN1 is possible, not the, sorry, only the E2 is possible, not the SN1. Many of the students, they will make the mistake here. Is it clear? With the NaCN, with the 1 degree alkali halide SN2, 2 degree alkali halide SN2, but 3 degree alkali halide upon NaCN and the AgCN, it will give you the E2. Clear? Now, next the same, sorry to say sir, but as taught by my teacher, this reaction is SN1, not SN2, even if the polar protic is not written, because Ag plus helps carbocation formation. Ag plus helps the carbocation formation, but when it will be helps the Ag plus, it will help the carbocation formation only when it is at the stable carbocation. Here, if it is, we are having here the Ag plus will be help the formation of the carbocation, but instead of here the Ag plus, Ag and this is Cn minus, it is there, right? Now the Cn minus being the strong nucleophile, it will be attack. Is it clear? Ag plus will be given the which one? Carbocation when it is attached to the stable alkali halide. Cn minus is not strong base. Cn minus is strong base, Nana. Now Ishan, you are having somewhat of the misconception over there, I think so. But my dear friend, I want to ask you that here how come the, where is that one? Here how come the SN1 will be possible? Sir, just this concept is okay na, that KCN or AgCN provided Cn minus which is weak base and strong nucleophile. Okay, so that it favors the SN1 over the SN2. This is the concept also. My dear friend, this is a confusion you are having with the 3 degree alkali halide, or which one? Ishan, for the which one you are getting confusion? For the which one you are getting confusion? For the 3 degree alkali halide, sir, how it has become the E2 you are asking, right? How it has become the E2 you are asking, right? Sir, how it is became the E2 you are asking, or any other? That concept is okay, fine. Maybe sir I am wrong and I am getting your point. My dear, here once again I will explain. Ishana, once again I will explain. Here if it is a CH3, here if it is a CH3, here if it is a CH3, and here it is a Cl. Okay. This one here my dear friend, Ishan, I got your point. I will explain. Listen carefully. Here the NaCN is a which one? NaCN is a ionic. Okay, very fastly it will be formed the Na plus and the Cn minus. Okay. That's what I am saying. This is a if it is acting as a which one? Weak base and it is a strong nucleophile. This is a what it will happen. There is no any polar protic solvent to happen the SN1. There is no any polar protic to happen SN1, or else there is no chance to attack from the back end to show the SN2. If the polar protic solvent, if it is given, this Cl minus, that polar protic solvent will get the bond energy, this Cl will be eliminated. There it will be the carbocation generated by the polar protic solvent. But polar protic solvent is not given. Then when the polar protic solvent is not given, then if it is want to show the SN2 reaction, it should be attacked from the back end. Due to the steric crowd, it is not having any chance to attack in the form of SN2. Done. That is, substitution is eliminated. Then cyanide, then what it should be act? It should be act as a base. Then readily it will be abstract the proton. Then it should show the elimination reaction. Right? Clear? There is no any chance of forming the SN1 over there. Only E2 is possible. There is no any chance of SN1. Only E2 is possible. There is no any chance of E1 also. And next point, you have said that your faculty or teacher has said that, sir, Ag plus will give you the carbocation over there. But one thing you have to say me. Here this carbon and this cyanide, silver cyanide. Nana, that's what it is acting. Cn minus is a weak nucleophile. You are saying E2 needs a strong base, Cn minus, but this is a weak base. Okay, but even though it is a base, it is acting, it is ready to abstract the proton. That's what I am explaining. Here you are saying that Cn minus is a weak base, that strong acids conjugate base is a weak base. Okay, that it is clear. Whatever the point you have said, that it is, I can agree. But my question is, here the Cn minus, there is no any chance. Then this nucleophile, or if it is attacked to the carbon, it will be act as a nucleophile. Then this Cn minus itself it is acting as some base, right? It can abstract the proton here. Due to that proton, it gets the elimination reaction can be happened. Is it clear? Then when it comes to the Ag plus, here due to the covalent character, here the Ag plus will not form easily. Due to the formation of which one? Due to the covalent character between this Ag and silver, here the Ag plus ion, it will not form easily. First this which one? Cyanide should be attacked. Sir, I did not understand what you are telling. Yogi, I think you have joined now itself, I think so. Yogi, you have joined now with, I think so. Now what I am saying, 3 degree alkali halide upon NaCN and the AgCN, it will readily undergoes E2 elimination, not the SN1. Ishan, is it clear? Still you are having any confusion? Ishan, still you are having? Sir, 1 minute, just let me clarify this. Okay, whatever the doubt you are having, you can ask. I am here to explain. Whatever the doubt you are having, you can explain. You can ask. But sir, I say it is true, E2 can happen here, which is a major path. Sir, H2 and OH minus is the same. The difference between the strong and weak base. You are saying for the NaCN case, or you are saying for the AgCN case? Ishan, you are saying it for the NaCN case, you are talking for the NaCN case, or you are talking for the AgCN case? Which case you are saying? But the tertiary chloride, no good, beta hydrogen, very hindered, E2 is difficult because steric clash, that's what I said. Here, even though it is, okay, I will explain. Now you are saying that it will not follow the E2 mechanism. AgCN. Okay, fine. In the AgCN case, then if suppose my question, listen carefully, if you are saying if this Ag plus and the Cn minus, if the Ag plus ion if it is got here, then very fastly the Cn minus will become the nucleophile, right? Then why the isocyanide will get? If you are thinking that if it is give the Ag plus ion simply in the solution, means you are saying that this Ag plus ion will make this carbocation very fastly, but my question is, if this carbon Ag and cyanide, if it is forming the ion of this Ag plus in the solution very fastly, means then the obviously the nucleophile should be the cyanide. Why it will become the isocyanide? That's the reason first Ag plus will not be it will not be formed in the solution. This isocyanide, whatever the basic strength of the nitrogen it is having, it will readily abstract that proton. Now, Ishan, is it clear? Ishan, is it clear? Is it clear? Or still any confusion? Now we'll move to the next another type of the nucleophile, that is clear. Now here the NaNO2 and the next with the AgNO2, NaNO2 and the AgNO2. If suppose the NaNO2 if they are given, now what is the reaction you will get? And if suppose if they have given the silver nitrate, and what is the reaction you will get? Now we will see. Clear? Now anyone in the live, once you just comment I. No clumsy, just think it from whatever the concept I said, just you think it from my end. My question is for you. You are saying that the Ag plus ion if it is formed, it will produce the 3-degree carbocation. Okay, that I can accept. But if the Ag plus ion if it is formed in the reaction, if it is formed, means here my question for you is, if this Ag plus ion if it is forming in the solution, means then Cn minus is the nucleophile, right? Then why the isocyanide will come? My question is, here the Ag plus is the, if the Ag plus ion if it is forming simply in the solution, means Ag plus ion will make the Cl carbocation, right? Clear? Carbocation. Then if this Ag plus is providing simply in the solution, means then the nucleophile should be the Cn minus. That is my question for you. Then the Cn minus, then the product should be the cyanide, then it should not be the isocyanide. There is clear. Now let it be. Ishan. Now Ansh. Okay, okay, Nana. Let it be, let it be. Okay, fine, fine, fine. Clear? Now, here there is no any complication. Whatever the whatever the doubt you are having, the Ag plus you are saying means this AgCN is a which one? Ag and the cyanide is having the covalent bond. This covalent bond, it will not easily break. When this covalent bond is, if it is easily not break, then how the Ag plus ion will be the form in the solution? That is my question. If the Ag plus ion, if it is forming in the solution, means Cn minus will be the nucleophile. Okay, okay, Ishan. Now we'll move with the another one with the sodium nitrate. Clear, the with the NaNO2, with the NaNO2 and the AgNO2. With the NaNO2, with the sodium nitrate and the with the silver nitrate. Now what it will give? Now we'll see. Now with the sodium nitrate and with the silver nitrate, what are the products we'll get? Now we'll see. Here the sodium nitrate, now how it will be? This is the Na. Now this is the O. Now this is O bond. Now here this bond is the ionic. This bond is the ionic. This bond is the ionic. Now when it comes to the silver nitrate, now the bond between this oxygen and silver is a covalent. The bond between this sodium and the oxygen is ionic. Now my dear friends, try to stop this type of the chatting. I hope, see, every student having the different approach and different thought to understand the faculty, because now some of them having the, see, for our hand itself we are not having the 5 fingers same. So the 5 people's mentality also will not be same. If he is liking the Pankaj sir, let him like. The rest other who are teaching from me, I was giving the well understanding content for you. Clear? Then if you like, you can follow my class. If not, you can leave. No, Ansh, I am not getting demotivated. I am not getting any demotivated. I am here to just to give you the 100%, because the chemistry itself is the very complicated. Very complicated. See, my dear friends, I am saying you, my general suggestion for you, I am saying you, chemistry is the very complicated subject. Many of the complicated topics will not be taught by the online faculty, because this type of the confusions will be created by the which one? The students. Some of the students will have the some approach, some of the students will have the some approach. So that's the reason why it is happening like that, why it is not happening like that. I was explaining very clearly, because chemistry itself, it is having the very much complications. That's the reason the very complicated which will provide the very complication reactions that the many of the online faculties, they will not teach. Clear? That I was explaining. No, whatever the doubt you are having, it is very clear that it is, I was cleared you, right, that among the AgCN case, for the AgCN case, it will act as a only one chance. There is no any substitution. Substitution is there is not having any chance. Only the elimination is possible, and that to the E2 elimination is possible. Okay, my dear Yogi, all the best. All the best for your JEE mains as well as the JEE Advanced. I hope you will get the 100 percentile in your chemistry. Clear? Okay, fine. Then you have came to my class. That is the success of my lecture. Instead of you have not seeing the Pankaj sir lecture and you are seeing my lecture, means there itself I was feeling so happy. Instead of seeing the Pankaj sir lectures, you are came into my live and you are watching, means there itself you get to know that how much standard I was teaching. Clear? Okay, fine. Now we'll move to the next lecture. Now with the NaNO2 and the AgNO2, if they have given, there is no any interruption. I just gave my opinion. Okay. That's itself, my dear friend. Yogi, already I said we are having the 5 fingers. Why the 5 fingers is not same? Our 5 fingers is not having the same size and their functions are different. So the same thing, the student understanding with the one faculty and the student understanding with the other faculty is different. If you are liking the Pankaj sir, it is well and good, and if you are liking my lecture, that is also well and good. But I am not demotivating you, or I am not saying anything. Just I am not complicating. I was just explaining the one doubt of the Ishan, what he has asked. Okay, right. Now let it be, Nana. Let it be. Okay. Now, here, now with the first one, with the 1 degree alkali halide upon NaNO2, if they have given sodium nitrate, and the next one AgNO2, silver nitrate, if they have given. Now, what are the major product we will get it here, and what are the major product? Now, what are the major product we will get it with the sodium nitrate, and what are the major product we will get with the silver nitrate? What are the major product we will get with the? Now, what are the major product we will get with the sodium nitrate, and what are the major product we will get with the silver nitrate? Now, what are the major product we'll get with the sodium nitrate? Already I explained you. Sodium nitrate. Now the bond between the sodium and the oxygen, actually we should not show the bond between this ionic. Actually this is wrong, because we cannot show the ionic bond in this manner. Actually we'll show the ionic bond. We will never represent the ionic bond. So here the nucleophilic site will be from the oxygen end. Here the nucleophilic side will be from the oxygen end. Then when it comes to the AgNO2, this Ag and the nitrogen, now the bond between them, it is a covalent. Sodium, yes. Now it will be attacked from the which end? From the oxygen end. Clear? Now this is a very important. Now what are the very important reactions? Now what are the reactions you need, Nana? Frinkelston we are having, the Schwartz we are having, Brodin Ansdecker we are having, SN1 we are having, SN2 we are having, E1 we are having, E2 we are having, aromatic nucleophilic substitution reaction we are having, aromatic elimination we are having. Yes. CH3, one is a CH2 and the ONO2. And which reaction it will give? Which mechanism it will follow? Which mechanism it will follow? Mechanism it will follow. Ethyl nitrate. Which mechanism it will follow? Which mechanism it will follow? SN2. Good. It will follow the SN2 mechanism. Now the attack will be from the which end? Attack will be from the which end? From the oxygen end. In this manner, the oxygen end, it will be formed. Oxygen end. Now the attack will be formed. Now in this case, one will be from the oxygen end. Now another will be from the nitrogen end. Right. Now we'll go with the 2 degree alkali halide. With the 2 degree alkali halide, now with the NaNO2 and Ag, right, AgNO2 with the 2 degree alkali halide, now what we will get? How come 1 degree halide will give you SN1? How come 1 degree halide will give you SN1? How come the 1 degree halide will give you SN1? 1 degree halide will not give you SN1, right? With the 2 degree alkali halide I am asking. With the 2 degree alkali halide. With the 2 degree alkali halide, one is a nitrate and one will be the next one. What is the product you will get? One you will get the nitro, one you will get the nitrite. Which mechanism it has followed? Which mechanism it has followed? Can anyone? Which mechanism it has followed? Can anyone say? Which mechanism it has followed? Which mechanism it has followed? Can anyone say? Sir, that was the previous question answer, sir. No, how come the 1 degree alkali halide will give you the SN1? My question. AgNO2, how it will give you the SN1? Both are SN2 only. Both will give you the SN2 only, not the SN1. Both will give you the SN2 only. Now, if the 2 degree alkali halide upon the NaNO2 and the AgNO2, NaNO2 and the AgNO2, now what is the major product that it is involved here? What is the major product it will be involved here? What is the major product that is involved here? What is the major product that is involved here? SN1. Elaya, hi. Elaya, hi. Now one you will get it as a nitrito. Nitrito is a major product. Here this is a nitrito is a major product. This is a nitrito. Nitrito is a major product. Nitrito is a major product. Now here the nitro is a major product. In this case, the nitro is the major product. In the AgNO2 case, it is nitro, and in the NaNO2 case, it is a nitrito. Here the mechanism followed is SN2 only. Here the mechanism followed is SN2 only. Sir, here NaNO2 will do SN2 and AgNO2 will do SN. No, here both it will do the SN2 only, not the SN1. My dear Ishan, once again I am saying you, listen, where you are getting confusion means, already I explained very clearly, the silver and the nitrogen, the silver and the oxygen is covalent. it is covalent. If it is a covalent, now listen, I got it your point. Once again I will explain with the clearly. See, you are saying that CH3, C double bond, CH3, here it is a H and here it is a Cl. Okay, now here it is a Ag, O, here the N double bond O. Okay, now you are saying that this Cl will be, this Ag, when it has eliminated without the bond pair of electron, with leaving the bond pair of electron, this Ag plus it should be formed, and the nucleophile should form the nitrito, right? Nucleophile should form the nitrito. Done. And we are having the chlorine. Now this Ag plus can abstract this bond pair of electron of the Cl minus and it should be eliminated. And you are saying that here the CHCl3, now here it is a H and here it is a CH3. Then here it will get the positive charge. Then if you get the positive charge, then the major product should be, nitrito. Then here the major product should be nitrito. Then actually with the 2-degree alkali halide with the AgNO2, the major product is nitro. The major product is nitro. Then if the major product is nitro, then it should be attacked from the nitrogen end. Not from the oxygen end, right? Then here the Ag plus, if it has provided, means this nitrito is a nucleophile and the major product should be the nitrito. But actually 2-degree alkali halide upon AgNO2, the major product is nitro, not the nitrito. Is it clear, Ishan? Sir, in the NCERT it is written AgNO2 with a 2-degree alkali as SN1 to give the nitro product RNO2. Is it wrong? With the 2-degree alkali halide, where it has, in the 2-degree alkali halide it has given. See, my question for you, I was saying you, here is it clear, the doubt whatever you are having? Now here I was explained it very clearly, that what I am saying you, the chemistry here itself it will give you somewhat the complication. Here whatever I was written here, is it clear for you? Here you are saying that Ag plus will provide you the carbocation. Ag plus will give you the Cl minus. That what I am saying you. If you are saying that, then the product should be the nitro. That what I am saying you. If this Ag plus, if it is provided the carbocation here, means then this Ag plus should be, first this carbocation it should form the bond with AgCl. Then here the oxygen should get the negative charge. If the oxygen, if it is getting the negative charge, means then the major product should be the nitrito. Then the actually 2-degree alkali halide upon the AgNO2, it is giving the nitro, not the nitrito. That what I am saying you. From the that time. Then the major product is the nitro, means it will be attacked from the back end. Nucleophilic substitution reaction, it has attacked from the back end and it has did the SN2 reaction, not the SN1 reaction. Is it clear? Still you are having any confusion? Okay? Because in the last year JEE Mains, in the last session, in the January session, they have asked this question only. Mechanism is very, very important. Ishan, is it clear? Still you are having any doubt? Ishan, still you are having any doubt, or is it clear? But okay, okay. Here, my dear friends, then you justify the concept which I was saying then. Okay, if you are saying that Solomons it is the 484 and the 485, now 2 degree and the 3 degree it is the SN1 dominating, means now whatever the concept it I said, now try to give me the answer for this one. Then the 2 degree alkali halide upon the AgNO2, the major product should be the nitrite. Then why it has came nitro? And which mechanism it has followed then? Nitro. Then which mechanism it has followed then? Nitro. Then the Cl should be, if it is eliminated, then if the Cl should be eliminated, the nitrogen should be attacked, right? Then which mechanism it has followed then? Now Ishan, my sincere suggestion for you, actually this is my mail ID, sir. It will take me some time to write it because if science. Okay, now actually this is one of my, this is my mail ID. You can whatever the doubts you are having, you just text it to me to my mail. This is beginners chemistry 97 @gmail.com, or if not, I am having the channel, right? Now this is the my mail ID. Whatever the doubts you are having, you can text me to that mail. Whatever the doubts you are having, I will clarify you. Okay, if you are getting a less time to type and all. Okay, that is my mail ID. You can send a whatever the doubts you are having, you can text it for me, so I can clear it for you from my end. What are the doubts you are having? What are the misconceptions you are having? See, that's the reason I am saying you. Chemistry itself will you give the more misconceptions. One path it will be understand, or one it will be clear from the one end, and one it will be clear from the another end. One it will be clear from the another end. Is it clear? Right. Now here it is a CH3. Here the CH3. Now here it is a CH3. Now here it is a Cl. Now with the sodium nitrate and the silver nitrate. With the sodium nitrate and the silver nitrate. And what are the products A and B? 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 Then actually with the 2 degree alkali halide, it will give you the AgNO2, but actually the major product for this here, this one, the AgNO2 is a major product for that one. Which page number, Nana? Whatever what you are saying, which page number? 484. Okay, you can text me through my mail. Whatever the doubts you are having, I will clarify you over there through the mail. Clear? Now after the ending of this live, you can text me the questions whatever you are having, or else I can give you my mobile number through in the mail ID. You can call me, and you can whatever the misconceptions you are having, I will clarify for you. Okay? Done. Right. Next we'll move. Now here the, oh thank you team player, thank you. Right. Now here with this one chlorine Which one? With the 3-degree alkali halide. Hi. Hi Pradyut. Hi Atrava Dubey. No. Okay, hi. If I misspelled anyone names wrongly, sorry from my end. Okay. If I misspell anyone names wrong, that is sorry from my end. Okay. Now, if they have given here the nitrite is the major product. Here the nitrite is the major product. Then here it will be the nitro is the major product. Here the nitro is a major product. Clear? Done? Right. The next very important concept that we are going to study. Next one. Thank you, Space. Prince, you are, I don't know you are in the live from the starting or not. You are coming and you are going. Prince, no. That much high capability I may have or not, that it should be said by you itself. My name is Naveen Kumar. Pradyut, my name is Naveen Kumar. I was here only just to teach you, Nana. I just don't want you any fame or anything. I don't need any fame. Just my intention is to give you the free content for you in your chemistry, and it should be the high percentile. Just once if you have scored very much good marks in your any entrance exam, just you think about me and give you the simple thanks that it will be helpful for me, and whatever the hard work I was doing, it is no. Pranit, is it okay? Fine. Clear? Done. Next. Now the next we'll move with the very important one, that is a very one, nature of bonding. Next one we are going to see the nature of bonding, but many of the one direct question they will ask for the nature of the bonding from the alkali halides. That is, if the suppose you have the given methyl fluoride, methyl chloride, methyl bromide and methyl iodide, if they have given among the 1, 2, 3 and 4, among the 1, 2, 3, 4, which is having the higher dipole moment order they will ask. Can anyone say dipole moment order for this one? Can anyone say what is the dipole moment order for this one? Can anyone say the dipole moment order for this one? Dipole moment order. I'm asking order. Dipole moment order. One, two, three, four. Rest any other? Rest any other? Rest any other? 1, 2, 3, 4. Still rest any other? Rest any other? I think that is an exception. Now, actually the answer is 2 greater than 1 greater than 3 greater than 4. No. The answer is 2 greater than 1 greater than 3 greater than 4. 2 greater than 2 greater than, 1 greater than, 3 greater than 4 is a dipole moment order for the given alkali halides. This is one of the CH. No, this is that what most of you are thinking that actually this is a 2 greater than, 1 greater than, 3 greater than 4. Actually the answer is 2 greater than, 1 greater than, 3 greater than 4. Now why? Because now I will explain. Now listen. Now the dipole moment is equal to charge into distance, right? This is a charge into distance. But when it comes to the methyl fluoride, in the methyl fluoride case, charge is more dominating, but distance is less, right? Less dominating. Then when it comes to the methyl chloride, in the methyl chloride, charge is dominating as well as the distance is also dominating, somewhat higher than the methyl fluoride distance. Charge is also dominating as well as the distance is also dominating than the fluoride. No, there is no any exception. I was saying you clearly. Listen, here dominating, because here the fluorine being the more electronegative, 2p overlapping, and it is a 2p overlapping, and the bond length is less, distance is less. But here the chlorine and the carbon, it is having the charge is somewhat high. Charge is also dominating for the chlorine and the distance is also dominating for the chlorine. Okay, then actually the order will be 2 greater than, 1 greater than, next one 3 greater than 4. This is one very important molecule. Then with this type of the questions, they may confuse you. So you have to be very careful with this type of the questions. If the dipole moment, if they have given, the order will be 2 greater than, 1 greater than, 3 greater than 4. Is it clear? Okay, done. Right. Fine, done. Next, now we are going to see the preparations of haloalkanes. That only I did. Dipole moment is equal to charge into distance. That only I did. With the charge into distance only I did. Now, the preparations of haloalkanes. Now, the preparations of haloalkanes. Now, in the preparations of the haloalkanes, first from alcohols. First one, here if the 1 degree alcohol, if they have given 1 degree alcohol, this is one very important one, Lucas reagent. With the Lucas reagent, now 1 degree alcohol and the 2 degree alcohol, with the 1 degree alcohol, 2 degree alcohol upon the Lucas reagent, with the Lucas reagent will get, now you see, now the 3 degree alcohol upon the Lucas reagent, now we'll get the instant turbidity. Now with the 2 degree alcohols, we'll get the 5 to 10 minutes turbidity. Now with the 1 degree alcohol, hours may or may not come. Yes. Raza, it is for all. Gross method only. Raza, it is for NEET as well as JEE. NEET as well as JEE, both. NEET as well as JEE. Now, next one. Now, res, anti-Markovnikov rule also, it will be Done. Now next we are going to see the mechanism for this one. Lucas reagent. First one, this is a which one? If you take the 3 degree alcohol, depending upon the stable carbocation it has generated, it will give you the which one? 3 degree alcohol, it will give you the which one? Stable carbocation. Now the concentrated H2 SO4, now concentrated HCl, this oxygen lone pair of electron will be abstract this proton very fastly. When it has abstracted this proton very fastly, it will form the oxonium ion. No, here the preparations of the haloalkanes. Now here it will form the oxonium ion. Now it will take this bond pair of electron and it will be eliminated. Now due to this stable carbocation it is provided. Now it will provide the instant turbidity. After providing the stable carbocation, now the Cl minus which it is there, that Cl minus it will go and attack and will get the which one? Haloalkane in this manner. Now with the 1 degree alcohol and the 2 degree alcohol also same thing. Now here you have to say me now among the 1, 2, 3, which one will give you the instant turbidity? Among the 1, 2, 3, which one will give you the instant turbidity? Among the 1, 2, 3, which one will give you the instant turbidity? Which one will give you the instant turbidity? Order. What is the order? 1, 2, 3. 1, 2, 3. Now, what is the order? 3, 2, 1. 3 greater than 2 greater than 1. No. Here the order is 1 greater than 3 greater than 2. Now the instant turbidity, first CPM carbocation will be generated here. The first it will give. Now among the 3 degree carbocation and the benzyl carbocation, 3 degree carbocation will give you the instant turbidity than the 3 degree carbocation will give you the instant turbidity than the which one? Benzyl carbocation. I explained very clearly. So no. Among the 3 degree carbocation and the cyclopropyl methyl carbocation is more stable carbocation among the all. Cyclopropyl methyl carbocation is more stable. My dear friends, try to remember, and this is a very, very important molecule. Among the 1, 2, 3, if they have given, which one is a, see, this is the level of the chemistry. This type of the misconceptions compounds in the online, none of the faculties will give you, because they need the views and they need the something something they should be gained from their views or anything, because this type of the concept is somewhat more complicated to make the students understand. So here my motto is to be clear misconceptions of the chemistry what they are having. Clear? Sir, you can ask. Ishan, you can ask. No problem. I am ready to explain for you. Actually, the order for this one is 1 greater than 3 greater than 2. Not the 1 greater than 2 greater than 3. Now I will explain here. Now the cyclopropyl methyl carbocation, due to the dancing resonance of the sigma bonds, it has formed. Now it will stabilize this carbocation very fastly. It stabilizes this carbocation very fastly. Sir, in 3 compound, all the molecules of alkane gives electron to the main carbon, so that in case it will be the third option for the fastest turbidity. No. Now my dear friend, I know, I got it. Whatever the doubt you are having, I will explain. First one will be the cyclopropyl methyl carbocation. CPM carbocation is more stable carbocation among the benzyl, among the which one? Tertiary carbocation. If they have given are 3 degree phenyl carbocation, if they have given here the cyclopropyl 3 degree of the cyclopropyl methyl carbocation is more stable. Blindly believe that one. 3 degree of 3 cyclopropyl methyl carbocation and the benzyl carbocation, if they have given cyclopropyl methyl carbocation is more stable. Clear? Is it clear? But the tertiary, but butyl alcohol is 3 degree alcohol, so stable carbocation, so instant turbidity. My dear friend, now here you can see, now you are thinking that here the benzyl alcohol, this benzyl alcohol will provide the benzyl alcohol will provide the carbocation here, and the 3 degree carbon, here the 3 degree carbocation it will be provided. But here you can see this carbocation is stabilizing by only 6 pi electrons. This carbocation is stabilizing by only 6 pi electrons. But here this carbocation is stabilizing by the 9 alpha hydrogens of plus H effect. And this carbocation is having the sp2 carbon of minus I effect. This carbocation is having the what? Plus M effect of the benzene as well as the minus I effect of the benzene. Clear? This carbocation, for the benzyl carbocation, it is having the plus M effect of the which one? Benzene as well as the minus I effect through the sigma bond. And when it comes to this 3 degree carbocation, it is having the 9 alpha hydrogens of the plus H and 3 plus I groups of the methyl groups. So that's the reason compared to the benzyl carbocation, 3 degree carbocation is more stable. Blindly believe this one. That's what I am saying you. I explained here very clearly. Listen. This benzyl is having minus I effect of the. This one is only true, Nana. This one is only true. Whatever the Google you are, see, in the Google whatever it is giving, don't believe it. It is AI generated. Actually, according to the concept, this is true. According to this one, this is true. Because here due to the minus I effect, this is the benzene is giving the plus M effect to the carbon with the 6 pi electrons, but benzene the same thing with the minus I effect, it is pulling. But when it comes to here, both are plus H effect of the 9 alpha hydrogens as well as the 3 plus H effect. So 3 degree carbocation is more stable than the benzyl carbocation. Blindly believe this one. blindly believe this one. You can trust me. You can trust me. This is the clarity of the explanation. More than this I cannot say. If in the Google also, if they have given, don't believe that one. Okay, fine. Okay, now actually the order will be 1 greater than 3 greater than 2. 1 greater than 3 greater than 2. This is the order actually. For the instant turbidity. Okay, fine. Right. Next. Raj, actually my Hindi is very poor, Nana. I cannot explain you in the Hindi. Sorry, Raj. Because my Hindi is I don't know the Hindi actually. I can explain you in English itself. Actually, my motto is to be teaching my own language of the Telugu, but many of the other state students are also coming and joining my lecture, so that I was feeling so happy. So not to get any disturbance or not to get any interrupt for the other students, so I was teaching in the English, even though my English is bad. That's what I'm saying you. My dear friend, I did the MSc chemistry and I was appeared for the CSIR exam. Clear? Then I was read many books and I was approached with the many faculties, and when I was discussed, at the end I got that clarification. Okay, now the next type of the preparation we will see. Now from phosphorus halides. Now with the phosphorus halides also we can prepare the which one? Haloalkanes, that is a PCl3. Now 3 moles of CH3Cl plus H3PO3. Now can anyone say what is the basicity of this H3PO3? What is the N factor for this H3PO3? Whatever the see, this type of the questions only they will ask. Now 3 moles of the alcohol, when you have taken the PCl3, now it will form the alkali halide and the subproduct it will give the H3PO3. What is the basicity or what is the N factor for this one? What is the N factor for this one? Don't rush to give the answer. Don't rush to give the answer. Praneeth, it is wrong. 3 is wrong. Don't rush to give the answer. 2, because H3PO3, the replaceable hydrogens are only 2. This is a H3PO2. This is a H3PO2 structure. H3PO4 is 3. Okay, good. Okay, fine. Clear? Now H3PO3 N factor is 2. H3PO3 N factor is 2. H3PO4 3. Okay, done. Right? Next from the thionyl chloride. This is also one best preparation method for the alkali halide. From thionyl chloride SOCl2, and this process we call it as a Drazen's method, and this one we call it as a Drazen's method. Now here they will ask you in the statement based question, Anna, you have to be very careful. Now alcohol, what is N factor, sir? N factor is nothing but the replaceable hydrogens. N factors is nothing but replaceable hydrogens from the given acid. If here the replaceable hydrogens are 2, so its N factor is 2. Then the alcohol in the presence of thionyl chloride. Alcohol in the presence of thionyl chloride. Then what it will give? It will give the Cl plus HCl and in the presence of SO2 gas. This here the byproducts are the gases. Here the byproducts are the gases. Now here we will get the which one 100% yield. By this reaction the alkali halide which we got the 100% yield because the byproducts are the gases. The byproducts are gases. Is it clear? Next we are going to see the halogen exchange methods. Halogen exchange methods. Halogen exchange methods. In these halogen exchange methods, here this type of the questions also they are asking. In the advanced, this year advanced exam, they have asked the question from the Finkelstein reaction. This year advanced paper you can see. Now they have stressed the question from Finkelstein reaction. Finkelstein reaction. You have to be very careful with the Finkelstein reaction also. Now what is the meaning of the Finkelstein reaction? Finkelstein reaction, iodoalkanes are easily obtained from the corresponding alkanes. Here the bromides are chlorides in the presence of sodium iodide heating in the presence of acetone. Clear, readily it will form the iodide plus NaBr. Finkelstein and the salts are very very important. Yes, NaBr is a less soluble than the NaI in the acetone. Actually NaBr is a less soluble than the NaI in the acetone. Clear? Done. Now this is a Finkelstein reaction. Here whatever the NaBr you have taken, you may get a doubt, sir, why not we can take the which one? Why not we can take the alkali iodide? Alkali iodide if you take, and if you take the NaBr, what it will form here? You will get the, what you will get here, the R alkali bromide you will get, and you will get the NaI. NaI is the less soluble in the acetone. It is less soluble in the acetone because NaBr, actually the NaBr is less soluble in the acetone than the NaI. Right. Total duration of this session. Now I will end Nana. Now with the Schwarz reaction, Brodin-Unstedker reaction, I will say and I will end. Then tomorrow I will start the aromatic nucleophilic substitution reaction, which is very very important, and followed by questions. Now the Schwarz reaction, Brodin-Unstedker reaction I will explain and I will end, because it's almost the class has started 2.5 hours ago. Schwarz reaction. Now the Schwarz reaction, now here this is also one halogen exchange method, is more convenient for the inorganic fluorides. This is more convenient for the inorganic fluorides. Nana Yashwant, any doubt you are having? Any doubts you are having? Any doubts if you are having, you can ask. I will explain. Any doubts you are having, or in the any concept you are having any doubt, or in the any reaction you are having any doubt, you can ask me. I can explain, because you are saying that tomorrow you are having the exam, right? No, Nana. Actually, Ishan, I can teach you in online, because I was not here for the money. Ishan, I was not here for the money. Actually, my motto is to give the free content to the students. Actually, first of all, I thought of start of the tuition itself, but the students, when I teach it privately, when I say the content, he will listen, but after some time he will get forget. But not to get forget only, I was started in the YouTube, so that it will be like a reference. That class will be like a reference for you. Whenever you have started your lecture, whenever you are able to study, then you can open your book and this video will be in the reference. If I teach you in the private, when I teach you, it will be very clear. But after some days, if you close the books and if you open, again you will get the doubt. Clear? Done? Now, my motto is that the chemistry itself is the misconceptions you are having. Whenever you listen, it will be very good for you. But once if you forget, because see, my dear friend, I don't want any money actually. You know, I was working in one institution. My institution is paying good for me. But even though this is not at all my work actually, even though I was giving my personal time, actually I used to work, I used to go to the office at 8:30 and I used to come at 5:30. Daily I used to teach the 4 classes continuously, 6 hours non-stop teaching will be there for me. Then after that just 2 hours of the doubt sessions will be there, and the 5:30 I will come. I will face wash it, and again I will set up the YouTube. This YouTube setup, laptop, digitizer, camera, everything I have to set up. There is no any personal life for me. At the 7:30 I used to start the I used to start the live, and I used to end at the 10:30. Actually this is only to give you the free content, and I need the success from you in your any entrance exam you are preparing. I don't need any money or anything. No, that's what I'm saying. First already GOC I was finished. Then after that I was finished the hydrocarbon. Now I was going to finish the haloalkane haloarine. Then after that I will finish the alcohols, phenols, ethers. Then after that carbonyl compounds. Then after that amines. Then after that biomolecules. Then after that I will go to the coordination chemistry. Then after that D and F. In that sequence I will go. Then after that solutions, electrochemistry, chemical kinetics. Then after that the first year, atomic structure, like that. Sir, I have backlog in the physical chemistry. Everything one by one it will come. Now the Schwarz reaction. What is the meaning of the Schwarz reaction? This is more convenient for the inorganic fluoride. You can check it in my playlist. You can check it in my videos playlist. Already I was given the GOC. Thank you, Rohan. Thank you for it. Ethyl bromide. Now Hg2 and F2. Hg2 and F2. Next, from the next Monday I will start the alcohols, phenols, ethers. Monday I will start. Every Monday, within 1 week I will finish the one chapter. Within 1 week I will finish the one chapter. Now by Sunday, total haloalkane haloarenes questions, total haloalkane haloarenes questions will be there, and the Monday alcohols, phenols, and the one I will post the schedule for the next week in the community tab. You can cross check. Monday what is the class and the lecture and the duration, and the Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. I will post the class timetable and what are the content I was going to teach on that day, particular day. I will post it in the community tab. You can cross check over there. This ethyl bromide in the presence of Hg2F2, what it will give? This will give you the ethyl fluoride plus Hg2F2. This is a one Schwarz reaction. Clear? This is a Schwarz reaction. Now next type of the reaction we are having the Brodin Ansdecker reaction. The Brodin Ansdecker reaction. Now in the community tab I will post the schedule. You can cross check over there. Now this is in this reaction, one carbon will be less at product side. One carbon will be less at the product side. Now you can see this is the one. Now carbonyl carbon of the silver. Done. Clear? Now if suppose if they have given this one upon the Br2 in the presence of CCl4, what you will get? You will get the which one? Alkali bromide plus CO2 in the AgBr you will get. Clear? This is the Brodin and Unstedker reaction. This will follow the reaction mechanism. Iodines from the esters instead of the alkali halides. This reaction known as a what? Siemens reaction. I hope it is clear for you. I hope it is clear for you. Anyone if it is in the live? The one who are in the live? The one who are in the live, once you just text me hi. Once you text me hi, so that I can end the session. And tomorrow is a very, very important lecture, that is aromatic nucleophilic substitution reaction, elimination. Okay, ipso and the sign product will be there. Yes. Pranit, you can leave now. Okay. Right. I am also ending the class. Yashwant, the rest, if any other are having any doubts, if they are having the doubts, they can stay. Rest they can leave. Yashwant, what are the doubts you are having? You can ask me, I will clear. Good night, Pranit. Good night. And be focused on the maths and physics. Pranit, be focused on the maths and physics. 3 subjects you have to balance. Yashwant, what are the doubts you are having? You can ask me. I will clarify you. What are the doubts you are having? SN1 reaction. Should I explain SN1 reaction? Anyone rest, the one who are in the online, if you are having any doubts or any clarification or anything, if you need, you can ask me. Good night, Ishan. Good night. And you too maintain, Ishan, you too maintain the balance. Try to balance the maths and physics also, because in the JEE the chemistry is a which one rank deciding factor, but the balancing of the 3 is very, very important. Rest other, any other, if they are having any doubts, you can ask me, I will explain. Now Yashwant is having the doubt in SN1. Okay, SN1. Now listen. Now first, what is the meaning of the SN1? Now in the SN1 reaction means, sir, I am having PCMB. Ishan, you are from which state? May I know? I am in 12th. I will give both NEET and JEE. Actually, when it comes to our Telangana board, the student who was enrolled for the PCM, he can write only JEE. The students who are enrolled for the PCB, they can write only the NEET. They are not having a chance of writing both. Either they can write only the JEE, either they can write only the NEET. For this Telangana students are having only this one. West Bengal, Kolkata. Okay, good. But in our Hyderabad, it is not having a chance of writing both NEET as well as the JEE. Okay. Yashwant, are you there? Now listen, for the SN1 reaction, now the SN1 reaction to be happen, if you take any 3-degree alkali halide, in the presence of aqueous KOH, Yashwant, inama, ఇది మన SN1 రియాక్షన్ చెప్తున్నా ఇను, ఓకేనా? క్లియర్? తెలుగే కదా యశ్వంత్ రెడ్డి? తెలుగులో ఎక్స్ప్లెయిన్ చేస్తా ఇను. దిస్ aqueous KOH SN1 రియాక్షన్ అవ్వాలి అంటే ఫస్ట్ 3-degree ఆల్కలీ హాలైడ్ ఉండాలి. 3-degree ఆల్కలీ హాలైడ్ అన్నవి ఉండాలి, లేదా 3-degree ఆల్కహాల్ అన్నవి ఉండాలి. ఓకే, డన్. ఇప్పుడు ఈ ఆక్వస్ KOH అనేది నెక్స్ట్ క్రైటీరియా ఏముండాలి అంటే పోలార్ ప్రోటిక్ సాల్వెంట్ ఉండాలి. పోలార్ ప్రోటిక్ సాల్వెంట్ ఉండాలి. పోలార్ ప్రోటిక్ సాల్వెంట్ ఏంటంటే ఇక్కడ చూడు, పోలార్ ప్రోటిక్ సాల్వెంట్ రోల్ ఏంది అంటే ఇప్పుడు H2O ఒక పోలార్ ప్రోటిక్ సాల్వెంట్ కదా. H2O ఈజ్ ఏ వన్ పోలార్ ప్రోటిక్ సాల్వెంట్. ఇప్పుడు H2O ఇలా ఉంటుంది, ఇలా ఉంటుంది. ఇది పార్షియల్ నెగిటివ్ ఛార్జ్, ఇది పార్షియల్ పాజిటివ్ ఛార్జ్. ఓకే, ఇప్పుడు ఈ మన H2Oలో నేను ఏం చేస్తా అంటే ఒక NaCl వేస్తా. ఇప్పుడు మనకి ఏం తెలుసు, H2Oలో NaCl వేసినామంటే ఏమవుతుంది, ఆ NaCl H2Oని సాల్యుబుల్ చేస్తుంది. ఎందుకు సాల్యుబుల్ చేస్తుంది, అది ఎందుకు సాల్యుబుల్ చేస్తుంది అంటే NaCl వాటర్లో ఎట్లా డిసోసియేట్ అవుతుంది, Na+గా డిసోసియేట్ అవుతుంది. Na+గా డిసోసియేట్ అయినప్పుడు ఈ H+ ఏదైతే ఉంటుందో ఈ ఆక్సిజన్ మీద నెగిటివ్ ఛార్జ్ ఏదైతే ఉంటుందో, ఈ ఆక్సిజన్ మీద ఉన్న ఏదైతే నెగిటివ్ ఛార్జ్ ఉంటుందో ఈ రెండు ఇట్లా బాండ్ ఫామ్ అవుతుంది. అన్ని వాటర్ మాలిక్యూల్ ఆ H+కి ఏమవుతుంది, సరౌండ్ అవుతుంది. ఇట్లా సరౌండ్ అవ్వడం వల్ల ఈ సరౌండ్ అవ్వడం దాన్ని ఏమంటామంటే హైడ్రేషన్. దీన్ని మనం ఏమంటామంటే హైడ్రేషన్. ఇక్కడి నుంచి ఎనర్జీ వచ్చేదాన్ని హైడ్రేషన్ ఎనర్జీ అంటాం. క్లియర్, దీన్ని మనం ఏమంటాం, హైడ్రేషన్ ఎనర్జీ అంటాం. హియర్ ద హైడ్రేషన్ ఎనర్జీ ఈస్ హై. ఇక్కడ అన్ని H2O మాలిక్యూల్ ఈ Na+కి సరౌండ్ అవ్వడం వల్ల ఏమవుతుందంటే పోలార్ ప్రోటిక్ అనే సాల్వెంట్ల క్యాటయాన్ అనేది సాల్యుబుల్ అవుతుంది. దాని తర్వాత సేమ్గా Cl- వచ్చింది అనుకో, ఈ Cl- కూడా ఇక్కడ H2O ఇట్లా సరౌండింగ్ అయిపోతుంది. Cl- కూడా ఎందుకు, Cl అనేది ఒక నెగిటివ్ ఛార్జ్ ఆక్సిజన్కి, ఇక్కడ ఏంది నైట్రోజన్కి పాజిటివ్ ఛార్జ్ ఉంటుంది కదా. ఇట్లా ఈ హైడ్రోజన్కి పాజిటివ్ ఛార్జ్ నుంచి క్లోరిన్కి నెగిటివ్ ఛార్జ్కి ఇట్లా బాండ్ ఫామ్ అవుతుంది. దానివల్ల అన్ని H2O మాలిక్యూల్ ఇట్లా ఉండిపోతాయి. దానివల్ల ఏమవుతుంది, Cl- కూడా పోలార్ ప్రోటిక్ అనే సాల్వెంట్ల రెండు క్యాటయాను ఇంకా యానయాను రెండు సాల్యుబుల్ అవుతాయి. క్యాటయాన్ ఇంకా యానయాన్ రెండు సాల్యుబుల్ అయిపోతాయి అన్నమాట. సార్ Na+ getting surrounded with Mg+2 and Al+3 be surrounded by the H2O2. Yes, what I was not getting. Sir, Na+ is getting surrounded with Mg+2 and Al+3 be surrounded by H2O2. Yes, this Na+, whatever the ions it is having in the water molecule, it will be surrounded, right? It will be surrounded. Now, దాని తర్వాత ఇప్పుడు ఇక్కడ మనం ఏం తీసుకున్నాం, ఆక్వస్ KOH తీసుకున్నాం. ఆక్వస్ KOH వాట్ ఇట్ విల్ డూ, ఈ ఆక్వస్ KOH అంటే H2O అనే కదా. H2O is nothing but polar protic. H2O is nothing but polar protic. This polar protic, that H2O, what it will do, this polar protic H2O, this H2O will be surrounded to this anion in this manner. This which one, halogen. Halogens are the good living group. గుడ్ లివింగ్ గ్రూప్ అంటే ఏదన్నా సబ్స్ట్రేట్ నుంచి వెళ్ళిపోతున్నప్పుడు స్టేబుల్గా వెళ్ళిపోయేదాన్ని గుడ్ లివింగ్ గ్రూప్ అంటాం. ఇప్పుడు ఇక్కడ H2O ఈ Cl- తోని సరౌండ్ అయినప్పుడు దానికి బాండ్ ఎనర్జీ వస్తుంది. ఆ బాండ్ ఎనర్జీకి రావడం వల్ల అదేమవుతుంది, ఈ బాండ్ పేర్ ఆఫ్ ఎలక్ట్రాన్ని Cl తీసుకొని వెళ్ళిపోతుంది. Cl తీసుకొని వెళ్ళిపోవడం వల్ల మనకి ఇక్కడ ఏమొస్తుంది, ఒక స్టేబుల్ కార్బోకేటయాన్ ఫామ్ అవుతుంది. ఇట్లా ఇట్ విల్ ఫార్మ్ ద వన్ స్టేబుల్ కార్బోకేటయాన్. ఇది కార్బోకేటయాన్ స్టేబుల్ ఫామ్ అయిన తర్వాత ఇక్కడ హైబ్రిడైజేషన్ ఏంది అంటే దాన్ని sp2. ఇట్స్ హైబ్రిడైజేషన్ ఈస్ sp2 అయిన తర్వాత మనకి ఇన్కమింగ్ న్యూక్లియోఫైల్ OH- ఉంటుంది. ఈ OH- ఉండడం వల్ల ఈ OH- ఐదర్ ఇట్ కెన్ అటాక్ ఫ్రమ్ ద ఎబో ఎండ్, ఐదర్ ఇట్ కెన్ అటాక్ ఫ్రమ్ ద బిలో ఎండ్. ఇప్పుడు ఏదైతే ఈ లివింగ్ గ్రూప్ హాలోజన్ వెళ్ళిపోయిందో అటు సైడ్ నుంచి ఈ ఇన్కమింగ్ న్యూక్లియోఫైల్ వచ్చి యాడ్ అయితే దాన్ని మనం రిటెన్షన్ ప్రోడక్ట్ అంటాం. ఏ ప్రోడక్ట్ అంటాం, దీన్ని రిటెన్షన్ ప్రోడక్ట్ అంటాం. ఒకవేళ ఏదైతే హాలోజన్ వెళ్ళిపోయిందో దాని బ్యాక్ సైడ్ నుంచి వచ్చి అటాక్ అయితే దాన్ని ఏమంటాం అంటే మనం ఇన్వర్షన్ ప్రోడక్ట్ అంటాం. ఇది క్లియర్ యశ్వంత్? క్లియర్ అయిందా యశ్వంత్? ఇది SN1. ఎందుకు మనం పోలార్ ప్రోటిక్ సాల్వెంటే తీసుకోవాలి అని అంటే ఇక్కడ స్టేబుల్ కార్బోకేటయాన్ ఫామ్ చేస్తుంది. అదేది ఆక్వస్ పోలార్ ప్రోటిక్ అనే సాల్వెంట్ ఏం చేస్తుంది అంటే ఈ సిఎల్ని కార్బన్ నుంచి తీసేసి ఇన్వర్షన్ అదే అర్థం కాలే. ఇంకా ఏమైనా డౌట్ ఉందా? ఇంకా ఏమైనా డౌట్స్ ఉన్నాయా? ఇంకా ఏమైనా డౌట్స్ ఉన్నాయా యశ్వంత్? ఇంకా ఏమైనా డౌట్స్ ఉన్నాయా? యశ్వంత్ ఇంకా ఏమైనా డౌట్స్ ఉన్నాయా? ఇంకా ఏమైనా డౌట్స్ ఉన్నాయా? ఇంకా రైట్ యశ్వంత్, యు ఆర్ ఫ్రమ్ ఎక్కడి నుంచి రానా యశ్వంత్? యు ఆర్ ఫ్రమ్ వేర్? ఎక్కడి నుంచి యశ్వంత్? ఎక్కడి నుంచి యశ్వంత్? లక్ష్య పంచల్. లక్ష్య హాయ్ లక్ష్య. నౌ ఎనీ డౌట్? హైదరాబాద్ నేటివ్ ఏపీ. హైదరాబాద్లో ఎక్కడ యశ్వంత్? హైదరాబాద్లో ఎక్కడ? హాయ్ లక్ష్య. ఇంకేమైనా డౌట్స్ ఉన్నాయనా? ఇంకా ఏమైనా డౌట్స్ ఉంటే అడుగు, చెప్పేసా, క్లియర్ చేసేసా. లక్ష్య హాయ్. మే నో ఫ్రమ్ వేర్ ఆర్ యూ ఫ్రమ్? హలో రెహాన్ హాయ్. ఎల్బీ నగర్. ఓకే, గుడ్. నేను ఉండేది ఉప్పలే. యశ్వంత్ రెడ్డి, ఐఎమ్ ఫ్రమ్ మాది రాంపల్లి యాక్చువల్లీ, మేము ఉండేది ఉప్పల్లో. ఓకే ఫైన్. రెహాన్ హాయ్. ఓ సార్, ఓకేనా? ఓకే ఫైన్ గుడ్. రెస్ట్ ఎనీ అదర్ హూ ఆర్ ఇన్ ద లైవ్? ఇఫ్ యూ ఆర్ హ్యావింగ్ ఎనీ డౌట్స్ యూ కెన్ ఆస్క్ మీ. I can clarify your doubts. Meeku emanna doubts, if you are having any doubts you can ask me. The one who are in the live, if you are having any doubts you can ask me. I am ready to explain. If not, I will end the live. I can end the live. Should I end the live? Anyone in the viewers who are in the live? The viewers, sir, next week call start అవుద్ది కదా మాకు. స్టార్ట్ అవుద్ది. అవును, ఎస్, నేను కూడా ఇక్కడ మండే రోజు స్టార్ట్ చేస్తానన్నా. రెహాన్ థ్యాంక్ యూ రెహాన్, థ్యాంక్ యూ. దిస్ టైప్ ఆఫ్ ద అండర్స్టూడ్. దిస్ టైప్ ఆఫ్ ద మెసేజెస్ విల్ మేక్ మీ బూస్ట్ టు గివ్ యూ ద మోర్ హై కంటెంట్. మండే ఐ విల్ స్టార్ట్ ద ఆల్కహాల్స్, ఫినాల్స్ అండ్ ఈథర్స్. Monday I will start the alcohols, phenols, ethers. And yes. Sing, what are the doubt you are having, you can ask. Sing, what is the doubt you are having, you can ask. I can clear your doubt. What is the doubt you are having, you can ask. Rest. Okay, fine. I will post the timetable in the community tab. You can see over there. Yashwant, nenu community tab lo next class timetable pedtano. You can cross check. Now, what is the doubt you are having? Sing. Rest any other. If you are having any doubts, you can ask me. Rest any other. If you are having any doubts, you can ask me. If not, I will end the live. Anyone they are having? Sir, why aromatic ring opposes the nucleophilic reaction? Why the aromatic ring will oppose the nucleophilic reaction? Why they will oppose? Nucleophilic reaction will happen, right? Why they will oppose? Why they will oppose? Nucleophilic reaction will be happen. Okay. Why they will oppose the nucleophile directly? Because see, benzene, this is a benzene, right? This is a benzene. Okay, I will explain. Listen, this is a benzene, this is a chlorine. Okay, now for this benzene, this carbon, this carbon, this carbon, and this carbon, and this is a carbon, all are sigma bonds, and all are sp2 carbon, and these pi bonds are in this manner for the benzene, and these are the pi bonds for the benzene. Now the benzene, the delocalization will be happened in this benzene in this case. Delocalization. Now the delocalization will be happened in this case for the benzene. Benzene, the aromatic ring. The benzene aromatic ring will be in this manner. Then if suppose the nucleophile, if it is coming to attack from the back end, here this pi bond is a electrons, negative charge, and nucleophile is also a negative charge. Both will be repelled to each other. Then why it will show the nucleophilic addition reaction? It will not show. But actually it will show the addition elimination mechanism as well as the benzene mechanism it will show. Benzene, with the benzene mechanism it will show the nucleophilic reaction. Is it clear? No sir. No sir. Aryl halides. Aryl halides. Okay. Aryl halides, why it will not show? Because here this is, okay, fine. This is CH2 double bond CH, this is a Cl. Okay, now this pi bond is formed by the, how? This pi bond is formed in this manner. This pi bond is formed in this manner. Now here the nucleophile to come and attack, this nucleophile should come and attack from this end, means this pi bond is having the electrons and nucleophile is also having the electron. Negative charge and the negative charge both will be repelled to each other. Then how the aryl halides will show the nucleophilic addition reaction? It will not show. Benzene will not show and aryl halide also will not show. Sir, what is the partial bond character? Sir, do a session on JEE 25 PYQs. That's what I am saying, Nana. Once the chapter completed, now entire that chapter's PYQs with the JEE mains, NEET as well as advanced, all three combiningly I was doing, and every Sunday I was doing that PYQ sessions. Every Sunday I was doing the PYQ sections only. JEE, NEET, advanced, three I was doing PYQ sessions. Total week we are doing the content, Sunday we are doing the PYQs. Total week we are doing the content, Sunday PYQs. Now what is a double bond character? What is a double bond character? So what is a partial double bond character? I did not get you sing. Okay sir, okay, good. Any other still? Okay. Aishwarya, hi. Still you are having any doubt? Sing, still you are having any doubt? Hi Ellaya. Emanna? Sir, no sir, this is not. Aryl halide, this is only aryl halide, benzyl halide only you are saying, right? With the both the cases I explained. Alkali, with the alkali halide I explained, with the aryl halide I explained. Both the cases I explained. Both the cases I explained. You can see, my dear friend, with the, this is aryl halide. This is aryl halide. Whatever the doubt you have asked, this is aryl halide, benzyl halide. This is aryl halide. Why it will not give you? I explained. Now this is the alkyl halide. Alkyl halide. Why it will not explain? I explained. Still, if you are having any doubts, see, that's what I am saying. These pi electrons will be resonate in the benzene in this manner. Now if this nucleophile, if it is want to attack from here, if it is attacked from here, this pi electrons will repel this one. So that's the reason nucleophilic substitution reaction will not be shown for the aryl halide. And alkali halide also, here these electrons will be repel and it will not show. Okay, good. Rest, any other who are in the live, still you are having any doubts? Rest any others who are in the live are having any doubts? Any doubts? Still any doubts? If you are having any doubts, you can ask me. If not, I will close the live. I will end the live. Ellaya, you are having any doubts? Yashwant, you are having any doubts? Aishwarya, you are having any doubts? Singh, you are having any doubts? Now the doubts has cleared. No sir, all the doubts are cleared. All the doubts has cleared. Bhagya, Nampalli Bhagya. Hello sir. Hello Bhagya. Bhagya, which stream you are preparing for? JEE or NEET? No sir. Aishwarya, which stream you are preparing? Sir, I am having the problem in physics. What should I do? I am not the physics sir, Nana. Sing. Okay, for your sake, I will learn the physics and I will start the physics classes too for you. Okay? Bhagya, for which stream, I mean like for which exam you are preparing, for JEE mains or NEET or any other state any entrance exam? Aishwarya and Bhagya, you are preparing for NEET. Okay, for the NEET, as for the chemistry, I can ready to helpful for you, because every Bhagya, you are in first year or second year? I mean class 11th or class 12th? Aishwarya, you too. Sadguna, Satyan. Sir, is this for JEE mains and advanced? NEET. Good. Both. My motto is to be clear for you all. I was teaching for the JEE mains, NEET as well as the advanced. Content is same, Nana. Content is dropper. Okay. See, Bhagya, you are dropper, right? Now listen. 12th. Okay. Now in my channel, in the community tab, daily every week, what are the topics I will teach in that upcoming week, and what are the when the question PYQ sessions will be happened, when the class will be happened, and what is the time it is going to start. Adi nenu community tab lo already I'm going to post. మీరు ఒకసారి అక్కడ క్రాస్ చెక్ చేసుకోవచ్చు. అండ్ ఎవ్రీ సండే క్వశ్చన్ సెషన్స్ ఉంటాయి కదా, ఆ క్వశ్చన్ సెషన్లో మీరు మంత్ 1 వీక్ అంతా చదివింది ఆ సండే రోజు క్వశ్చన్ సెషన్లో క్లారిఫై చేసుకోవచ్చు, డౌట్స్ ఏమైనా ఉంటే. Memorize the periodic table, that it is you have to do it mnemonic, Nana. Daily if you read, see, one good suggestion I can give it for you. Now class 11th, that what I am saying. One good suggestion I can give it for you. What I can give, daily we used to woke up and we used to scroll the Insta, right? That is our habit. That is our habit to scroll the Insta. The same thing, just daily you read the periodic table in like the habit of it, so that it will be memorized for you. Sir, basics నుంచి చెప్పండి. అమ్మా నేను బేసిక్స్ నుంచే చెప్తాను. భాగ్య, నువ్వు ఒకసారి నా ఛానల్లో హౌ టు స్టార్ట్ ద కెమిస్ట్రీ బేసిక్ లేని వాళ్ళకి కెమిస్ట్రీ ఎట్లా స్టార్ట్ చేయాలి, ఆర్గానిక్లో బేసిక్స్ లేని వారికి ఆర్గానిక్ ఎట్లా స్టార్ట్ చేయాలి, మీరు కెమిస్ట్రీ స్టార్ట్ చేద్దాం అనుకుంటే ఏం బేసిక్స్ కావాలి అని నేను ఆల్రెడీ నా ఛానల్లో నేను చేశాను. సార్, దిస్ ఈస్ యూస్ఫుల్ ఫర్ 22. Obviously it will be very much useful for you, Nana. Sadguna, it is for the JEE mains, pure JEE Advanced and the pure NEET. Now the content will be also from the basics to advanced. Content is the same, but question levels of questions are different. Ante. So one day what I will do, one day I will go with the JEE PYQs, one day I will go with the advanced PYQs, one day I will go with the NEET PYQs. అమ్మా, ఇంకా నువ్వు డ్రాపర్ అంటున్నావు, ఇంకా స్టార్ట్ చేయకపోతే ఎలా అమ్మా? స్టార్ట్ చేయు. ఒక టైం టేబుల్ పెట్టుకొని మంచిగా, నీకు ఇంకా డ్రాపర్ కాబట్టి వాస్ట్ టైం ఉంటుంది. సో మంచిగా ఒక టైం టేబుల్ పెట్టుకొని ప్రాపర్గా ఈ టైం టేబుల్ నుంచి ఈ టేబుల్కి ఈ సబ్జెక్ట్, ఈ టైం టేబుల్ నుంచి ఈ టేబుల్కి ఈ సబ్జెక్ట్ అని పెట్టుకొని యూ కెన్ ప్రిపేర్. కెమిస్ట్రీలో నీకు ఏం డౌట్స్ వచ్చినా ఏం వచ్చినా కూడా ఎవ్రీ 7:30కి లైవ్ సెషన్ స్టార్ట్ అవుతుంది. ఆ లైవ్ సెషన్లో నీకు ఏమైనా డౌట్స్ ఉంటే నాకు అడగొచ్చు. లేదు ఇంకా నీకేమన్నా అడగాలి, ఇంకా నాకేమన్నా బుక్స్ ప్రొవైడ్ కావాలి సార్ అది అని అంటే ఇది మా మెయిల్ ఐడి. మా మెయిల్ ఐడికి కూడా మీరు క్వశ్చన్స్ కానీ ఏమన్నా పంపిస్తే నేను దానికి సొల్యూషన్ చేసి పంపిస్తాను. ఏదన్నా దిస్ ఈస్ మై మెయిల్ ఐడి. ఈ మెయిల్ ఐడికి నీకు ఏదైనా క్వశ్చన్ రాకపోయినా, ఏదన్నా బుక్ కావాలన్నా సరే, ఈ PYQs బుక్ కావాలన్నా ఏదైనా కావాలన్నా కూడా యూ కెన్ టెక్స్ట్ టు దట్ మెయిల్ ఐడి. వీ కెన్ ప్రొవైడ్ యూ ద సొల్యూషన్ ఫర్ ఇట్. సార్ ఇట్ వాస్ రిటర్న్ ఇన్ క్లాస్ 12th NCERT. Sir, can you try to give us timetable for JEE 2026? That's what I am saying. Aim once in a week. Daily classes untayamma, not in a once in a week. Now listen. Now I will explain the timetable. Now listen. Now timetable for the tomorrow class will be, the tomorrow's class will be on the basis of Haloarenes, complete Haloarenes. Tomorrow's class. Sunday 7:30 PM complete PYQs of Haloalkanes and Haloarenes. Haloarenes की Haloalkanes की complete PYQ session 7:30. Clear? Sunday రోజు. మండే నుంచి సాటర్డే నెక్స్ట్ మండే టు సాటర్డే we are having alcohols 7:30 Monday to Saturday 7:30 is the live. Alcohols, phenols, ethers. Alcohols, phenols will be the ethers. Monday to Saturday class. Concept I will explain. Sunday what I will do. This Sunday what I will do. The one who are preparing for the NEET, I will schedule the live for them. What are the best time for you? You just say me, or you can comment in the comment sections or in the community tab. కమ్యూనిటీ ట్యాబ్లో మీరు నాకు పర్సనల్గా చేయొచ్చు. కమ్యూనిటీ ట్యాబ్ ఇట్ ఈస్ దేర్ ఇన్ మై ఛానల్. కమ్యూనిటీ ట్యాబ్లో మీకు ఏదన్నా డౌట్స్ ఉంటే, ఏదన్నా కాన్సెప్ట్ ఏమన్నా కావాలి అని అంటే అక్కడ కామెంట్ చేయండి. నేను దాన్ని చూసుకొని మీకు ఏ కన్వీనియంట్ టైంలో లైవ్ పెట్టాలి, ఓన్లీ నీట్ క్వశ్చన్స్కే పెట్టండి సార్ అంటే నీట్ క్వశ్చన్స్కే పెడతాను. ఓన్లీ ఇఫ్ యూ వాంట్ ఓన్లీ ఫర్ ద నీట్ క్వశ్చన్స్ PYQs అండ్ ద కాన్సెప్ట్ దానికి పెడతాను. సార్ వీ నీడ్ ఓన్లీ ఆన్ ద బేసిస్ ఆఫ్ PYQs, ఓన్లీ ఆన్ ద బేసిస్ ఆఫ్ JEE అంటే JEE మీద పెడతాను. ఓన్లీ ఆన్ ద బేసిస్ ఆఫ్ JEE మీన్స్ ఐ విల్ కీప్ ఇట్ ఆన్ JEE. సార్ వీ నీడ్ ఓన్లీ ఆన్ ద బేసిస్ ఆఫ్ అడ్వాన్స్ మీన్స్ ఐ విల్ కీప్ ఇట్ ఆన్ ద అడ్వాన్స్. లేదమ్మా, ఆల్కహాల్ చాలా ఈజీ. సార్ టుమారో ఎట్ వాట్ టైమ్ ద లైవ్ విల్ స్టార్ట్? 7:30 PM. ఆల్రెడీ ద టైం టేబుల్ ఐ వాస్ పోస్టెడ్ ఇన్ ద కమ్యూనిటీ ట్యాబ్. Timetable every day, the next week what I am going to teach, that already I will post it in the community tab. You can cross check over there. Alcohols, phenols చాలా హార్డ్ అంటే మీరు ఆర్గానిక్ కెమిస్ట్రీ ఎలా స్టార్ట్ చేయాలి అని ఆల్రెడీ ఐ వాస్ డిడ్ ద వన్ బేసిక్స్ చాప్టర్స్ అంటే ఏం బేసిక్స్ కావాలి, అవి స్టార్ట్ కావాలి అని దానికి నేను ఆల్రెడీ వీడియో చేశానమ్మా. యూ కెన్ క్రాస్ చెక్ ఓవర్ దేర్. ఇంకా స్టిల్ యు ఆర్ హ్యావింగ్ ఎనీ డౌట్స్? ఇంకా ఏమైనా డౌట్స్ ఉన్నాయా? దిస్ సండే ఐ విల్ ట్రై టు గివ్ యూ ద త్రీ టైప్స్ ఆఫ్ ద లైవ్స్. ఒకటి JEE PYQs చేద్దాం, ఒకటి NEET PYQs చేద్దాం. మీకు ఏమైనా డౌట్స్ ఉంటే నేను ఆల్రెడీ ఆ కమ్యూనిటీ ట్యాబ్లో కామెంట్ చేయండి. లేదంటే ఆల్రెడీ ఐ ప్రొవైడెడ్ ద బిగినర్స్ కెమిస్ట్రీ మై పర్సనల్ మెయిల్ ఐడి. ఆ మెయిల్ ఐడికి మీకు ఏదైనా కన్సర్న్ ఉన్నా కూడా నాకు కామెంట్ చేయండి, అది నాకు పర్సనల్ మెయిల్ చేయండి. నేను అక్కడ మీకు క్లియర్ చేయడానికి ఎవ్రీ టైమ్ ఐ వాస్ రెడీ ఫర్ యూ. స్టిల్ ఇంకా ఏమన్నా డౌట్స్? స్టిల్ ఎనీ డౌట్స్? ఇంకా ఇంకా ఏమైనా డౌట్స్ ఉన్నాయా? షూర్ ఐ విల్ క్రాస్ చెక్ సార్. ఇన్ఆర్గానిక్ కెమిస్ట్రీ వెయిటేజ్ అయ్యా ఆర్గానిక్ అమ్మా, ఇన్ఆర్గానిక్ కెమిస్ట్రీ వెయిటేజ్ అయ్యా ఆర్గానిక్ కెమిస్ట్రీ వెయిటేజ్. ఇన్ఆర్గానిక్ కెమిస్ట్రీలో మన నీట్కు ఉన్నాయి 5 చాప్టర్స్. ఒకటి క్లాసిఫికేషన్ ఆఫ్ పీరియాడిక్ టేబుల్, ఒక నెక్స్ట్ డిఎండ్ఎఫ్, కెమికల్ బాండింగ్, కోఆర్డినేషన్ కెమిస్ట్రీ, మళ్ళా పీ బ్లాక్, ఫిజికల్ ప్రాపర్టీస్ మాత్రమే. అవి ఆల్రెడీ క్లాసిఫికేషన్ ఆఫ్ పీరియాడిక్ టేబుల్లో కవర్ అయిపోతాయి. ఇక మిగతాయి ఉన్నాయి కూడా డిఎండ్ఎఫ్లో కవర్ అయిపోతాయి. ఆ ఫిజికల్ ప్రాపర్టీస్ మనకున్నాయి 4 చాప్టర్లో. ఇంకొకటి ప్రాక్టికల్ ఇన్ఆర్గానిక్ కెమిస్ట్రీ, అంతే. ఇన్ఆర్గానిక్ కెమిస్ట్రీలో వెయిటేజ్, ఆర్గానిక్ కెమిస్ట్రీలో వెయిటేజ్ యాక్చువల్గా 33.3 అట్లా వెయిటేజ్ ఫాలో అవ్వాలి. కానీ ఆర్గానిక్ కెమిస్ట్రీ, ఇన్ఆర్గానిక్ అన్ని ఈక్వల్ వెయిటేజ్లో ఉంటాయి. మన డిపెండింగ్ అపాన్ ద పేపర్ సెక్టర్ ఆఫ్ ద మైండ్ సెట్ మీద డిపెండ్ అయి ఉంటుంది. అది మనం ఆర్గానిక్లో కొంచెం ఆర్గానిక్ వెయిటేజే ఎక్కువ ఉంటుంది కంపేర్ టు ద ఇన్ఆర్గానిక్. స్టిల్ ఎనీ డౌట్స్? ఓకే ఇషాన్, ఐ విల్ రిప్లై టు యూ వన్స్ ద లైవ్ ఎండ్. ఐ విల్ రిప్లై టు యూ. ఇంకా ఏమన్నా స్టిల్ ఇంకా ఎనీ డౌట్స్? ఎనీవన్? షుడ్ ఐ ఎండ్ ద లైవ్? Still you are having any doubts? Should I end the live? Okay Rana, I was ending the live. We can see you tomorrow. I was ending the live. We can see tomorrow. ఇంకా ఏమైనా కన్సర్న్స్ ఉన్నాయి అంటే అడగొచ్చు. If not, I will end the live. Shiva Bosa sir, which book is better for the question practicing for the NEET? Question practicing for the NEET, Disha is enough Nana. Disha publication is one good. Actually they are updating the questions for the JEE as well as NEET. Artif, okay sir, okay fine. Okay Nana, fine. Now I hope all the doubts whatever you are having I was cleared, I think so. Now I was ending the live session and we'll see you tomorrow. We'll meet you tomorrow at the 7:30. We'll meet tomorrow at 7:30. Bye, good night for everyone who are in the live. Okay sir, fine. The one who are in the live, I was ending the stream. Now we'll see you tomorrow. Okay sir, okay. 7:30 we'll see you tomorrow. Okay.